Hey guys, welcome to this LangChain masterclass for beginners. In this video, you're going to learn everything you need to know about LangChain so that you can start your own AI development journey. And by the end of this masterclass, you're going to learn everything that you need to know about LangChain so that you can go off and create your own RAG chatbots, create your own agents and tools, and use LangChain to automate tasks. And even though there's a ton of information in this tutorial, I've done my best to make it as beginner friendly as possible. You'll see as we go through this tutorial that I've structured everything to start out with the absolute basics so that we can build up a strong foundation. And from there, we're going to add in more advanced features and complexities so that you can see what LangChain is fully capable of. And because I want you to get started building your own LangChain projects as fast as possible, I've actually included over 20 different examples in this video so that you can just copy my code and start using it in your own projects. And to make things even easier, I have a link down in the description below where you can download all the source code in this video completely for free, and it would mean a lot to me if you could hit that like and subscribe button while you're down there too. Also, if you get stuck at all during this tutorial, you're in luck because I created a free Skool community for AI developers just like you. In the community, you can go over there and ask questions, get support, join our weekly free coaching calls, and we have over 1,500 different active members in the community, so it's a great place for you to meet like-minded AI developers on your development journey. So I definitely recommend checking out. It's completely for free, and I have a link down in the description below, so come over and join the party. But enough of that, let's go ahead and dive into the rest of the video. Alright, so let's go ahead and cover the outline for this tutorial so that you can understand what you're getting into and so that you can get the most out of this tutorial. So to start off, the first thing we're going to do is set up the environment on your local computer so that you can run the over 20 different LangChain examples that I've built for you guys. From there, we're going to start diving deep into each of the core components of LangChain. So to start off, we're going to start working with chat models. And this is basically how we're going to start interfacing with, OpenAI's ChatGPT. We're going to start working with Claude. That's all going to happen in the chat model section. And what we're going to do from there is we're going to start working with prompt templates next. And this is how we're going to be able to format the inputs that we pass over to our chat models. And this is really just helping us build up a good, strong foundation so that eventually when we start trying to automate tasks using our chains, which is my favorite part of this whole tutorial, we're going to be able to really understand how we can start, automating tasks by putting together chat models, our prompts, and other tasks, and really run them all together to automate your workflows. From there, we're going to start working with RAG. Now, this is a huge section of this entire tutorial. As you can see, we have a ton of different examples in here. And if you've heard of people chatting with their PDFs or documents, this is what they were doing, RAG, Retrieval Augmented Generation. So we're going to do a huge deep dive into this one. And then finally, what we're going to do to wrap up this tutorial is we're going to do a deep dive into agents and tools. And as you can see, we're going to start off with the basics, and then we're going to do a deep dive into agents, which are basically just, chat models. However, they can make decisions on their own and act. It's super cool how it works. And then we're going to do a deep dive into tools, and tools are how we're going to supercharge our agents to provide them more capabilities. So as you can see, we have a ton of information in this tutorial. So let's go ahead and start diving into the first section, which is going to be setting up your local environment so that you can run all the different examples inside of this code base. Oh, real quick, I want to mention, if you want to get the most out of this video to learn LangChain as quickly as possible, here's my recommendation. First, I recommend watching the video the whole way through on 2x speed, just so that you can understand all the high-level core concepts of LangChain. And then I recommend coming back through this video a second time and just skip to the part that you want to learn about for whatever project you're building. For example, if you're learning about RAG, I would definitely recommend just skipping down through the timestamps below to rewatch the RAG section and do a deep dive into the exact part that you want to learn about. This is how I go about learning new concepts, so I just want to throw it out to you guys too, so you can speed up your development journey and start building projects. So, all right, enough of that. Let's actually go in and start setting up your environment. All right, guys, so it's time for us to start working on setting up our local environment so that we can run all the different examples inside of this project. Now, inside of the README, I have outlined all the different steps that you need to take in order to start running these, and it's actually super straightforward. So let me just quickly walk you through it. To start off, we need to install Python, and we need to install Poetry. Python, I'm sure you know what that is. Poetry, basically, if you haven't heard of it before, it's a dependency management tool for Python. So as you can see, we have something called a PyProject.toml. And this includes all of the different dependencies that we need to install in order to run all the different examples that I've set up for you. And Poetry makes this super simple to do. So what you'll do, go over to click this link right here, and it'll walk you through all the installation steps to install Poetry on your local computer. And once you have installed Poetry, you'll be able to run commands like this. So Poetry to confirm that it's working. And you can see, yep, Poetry is working. It's giving me back information. And then from there, what we can do is once you're inside of your code base, and remember, all of the source code for this project is completely for free. Just click the link down in the description below and you can download it. But once you've done that, what you can do is type in Poetry install -- no root, and what it'll do is it'll go through and install all the different dependencies that we saw back over in our pyproject.toml file. Over here, it'll install it, and what's awesome is then we can eventually start to run commands like this, Poetry shell. And what this will do is it'll actually spin an interactive shell up that we can see right here. It actually has the name of basically our project that we're working on. You can see right here, it has our name of a project that we're working on and we've created. And we can actually start, running Python and actually start calling all the different example code bases that we have, all the different projects. So you can see we can do something like Python 1.chatmodels, and then we can start running, all of our different code examples. So if you've got this far, you are good to go for the rest of the course when it comes to Python. Now we just have a few more cleanup things that we need to do. First off, coming back to our README, is I mentioned that you need to update your environment variables. So when you download the source code, you will only see a .env example file, and this is where you're going to store your environment variables. Eventually, what we're going to do is you are going to rename this file to just .env, and what this will do is it'll become your environment variable folder so that whenever you go to run your, start using OpenAI and some of your other different projects, they require an OpenAI key or a Google key or, all these keys. And that's going to get stored in your environment variables. I've already have mine set up and we'll be walking through it later, but that's the second thing you need to do. And actually, in addition to that, go over to OpenAI, Google, Firecrawl, and actually start adding in those OpenAI keys. But we'll talk more about that later on. Okay, all right, enough of talking about environment variables. If you've gotten this far, everything should be working, and we can now move on to actually start playing with the code and diving deep into LangChain. So we're gonna go over next and start working with chat models. Hey guys, I meant to show you this quick tip that's gonna make coding inside of Visual Studio Code and Cursor with Python so much easier and solve a big headache that you'll probably have. So if you head over to one of your Python files, you'll notice that you have a bunch of squigglies inside of your project. And the reason why is because Visual Studio Code is not properly hooked up to the new Python environment that you just created with all the proper dependencies. So here's how we fix that. First, you're just going to open up a terminal down here, and what you'll do is you'll type in Poetry shell like we did earlier, and this will actually access, and you can see, yep, we're in the right shell. But the important part is it gives us the location of where this basically all of our dependencies were installed. So here's where the magic happens. You'll come down here and click that, interpreter path, and you'll say enter interpreter path, and then you'll just paste in the path you just copied. And whenever you do that, it'll actually get rid of all the squigglies because now Visual Studio Code or Cursor is hooked up to your development environment with Python. So now every time you add a new dependency with Poetry add or whatever you do, it'll actually, sync up and you won't have all those random squiggly marks even though you have the right packages installed. And just as a final note, if you ever well, I want to not use this Poetry shell environment anymore, all you have to do is just type in the word exit and it'll put you back to your base environment. So yeah, that's a quick crash course on Poetry and setting up Visual Studio Code. Enough of that, let's dive back into the video. All right, so it's time for us to dive into our first core component of LangChain, which is going to be chat models. Now, what the heck are chat models and what do they do? Well, a chat model is basically LangChain's way of making it super easy for us developers to talk to all the different large language models out there like ChatGPT, Claude, Gemini, and a bunch more. They abstract away all the complexity and allow us to basically have conversations with these models. So that hence chat and chat models. It's all about conversations. So what is super nice about LangChain, if we go over to their documentation, you can see they have a list of all of the models that they currently support. Now it is very important to mention that for this whole tutorial, we're going to be using version 0.2 of LangChain. This is the most up-to-date one, and a lot of the features in version 0.1 will soon be deprecated whenever they upgrade, probably in the next, 5-6 months from now. But enough of that. Let's dive back into chat models and talk about how we can use them. So as you can see, looking at chat models, here's a huge list of all the different models that we have access to. Some of these models are better at other things. And what's very interesting is chat models inside of LangChain, they provide different functionality, such as tool calling, outputs. Do they support outputting content in JSON? Are they multimodal, such as accepting images and audio? So that's what you can see at a high level going over here. And what's nice is if you want to work with any of these different models, you can just click, use poetry add, and you can type in the name of the package and you'll add it to the environment that you just set up a few seconds ago. So let's go ahead and do a deeper dive and look at Chat OpenAI, because that's the one we're going to be using mostly inside of this tutorial. So if we go over here to Chat OpenAI, you can do a deeper dive and look at some of the examples that they already have set up for you. So you can see, once again, they recap what it's capable of doing, and then they walk you through, yep, this is how you can start setting up your files to start using this new package to start chatting with OpenAI. And eventually down here, they dive into showing you, yep, this is how you can start actually using it, updating the models and so forth. But enough of their documentation. Let's go ahead and actually head over to the example that I created for you guys, where we're going to start at the absolute basics and work our way up so you can see what these chat models are capable of. So let's come over here, start looking at the code, and take it from here. And before we dive into the code on this specific file, I just want to give you a quick overview of what you can expect from each of these files. So what I'll do in each one of the examples that we're going to run through, I will try to provide documentation for you guys up top so you on your own can do a deeper dive into whatever concept we're just learning. For example, we just talked about chat models and I showed you a link, and I also did OpenAI chat models and we walked through another link. So in all the files wherever I point out something, you'll be able to go ahead and click those links and do a deeper dive on your own if you ever want to learn more about those topics. But enough of that, let's actually go ahead and start talking about chat models at a basic level. All right, guys, so let's walk through the 3 core steps that we need to take to start interacting with our chat models, in this case, our OpenAI chat model, at a super basic level. So the first thing that we're going to do is load our environment variables. And if you remember from the beginning, we set up a .env file, which stored all of our keys to all of the different platforms we were going to access. In this case, we're trying to work with OpenAI, so it's important that we have an OpenAI key. Feel free, if you haven't set that up, just head over to the OpenAI website, go create an account, and you'll actually be able to access your OpenAI key and bring it back and copy it, paste it over here. Now, once you have done that, what's nice is this load.env is going to add all those environment variables so that we can start accessing them in this file. And you might be wondering, like, Brandon, what the heck? I don't see us accessing the OpenAI key anywhere. Well, if we actually peek under the hood inside of the chat model, which actually gets imported from LangChain OpenAI, and that's actually, if you head back over to those packages that we had set up earlier, that's where it was stored. But if you actually hit Command on your keyboard, if you're on Mac, or Control, if you're on Windows, and actually click on it, you can actually start looking at the source code under the hood. And you can see, hey, in order to start using this chat model, you need to have this API key. And we're actually going to start using it. If you scroll down a little bit, you can actually see under the hood, it's actually automatically grabbing this environment key here, unless you pass it in manually. And just to give you guys a full tour, you could actually manually pass in your API key here. It's just not the safest manner, because if you accidentally save your OpenAI key to the public, other people could actually grab your API key from GitHub, and it's not the most secure. So that's why you're going to store everything in your environment variables file. Okay, enough of that. Let's keep chugging along to actually, walk all the way through this example. The next thing that we're going to do is, once we have created our chat model, which in this case, we're going to say we're using ChatGPT 4.0, but we easily could have done something like ChatGPT 4. We could have done something like ChatGPT 4, 3.5 Turbo. We could have easily changed things up. But once we've created that model, we can actually start now interacting with it and using it. And the key lesson here is we're going to interact with our models in pretty much everything in LangChain using the .invoke property. This is a function that really just, whatever we're using, it triggers its core functionality. So in this case, we're working with chat models, so it's going to go trigger off like, hey, OpenAI or Claude, start processing the request I give you. But when we're using chains or RAG or agents later on, everything uses .invoke. So that's a very key thing to keep in mind as you're working with LangChain. All right, so let's just keep walking through what's going on. Well, in our case, we're telling our model, hey, go perform this query for me, and we're going to get back a result. So let's actually dive into these results so we can see what's happening under the hood. And the way we're going to do that is we're going to open up our terminal, and let's close it out and give you guys some more space. But once again, we're going to use Poetry Shell, and this is going to open up that interactive shell that we created earlier, which uses, our new LangChain crash course environment. And what we can do is we can actually start calling this function. So we're just going to call it Python, and this is our chat model. So I'll do one tab, and it'll go ahead and autocomplete for me. And this is the first example, so I'll hit 1 and tab again, and it'll autocomplete. Now I can start running it. So let's actually go ahead and press enter and start looking what's happening under the hood. So here's what's actually super interesting. So you can see we had two print statements. One was for the full result and one was content only. So for full results, you can see that OpenAI under the hood gives us back a ton of information. They give us back the content, which is the exact answer we wanted. 81 divided by 9 is 9. But then they give us this metadata, which is like, how many tokens did we use? Which, basically, why did we finish? There's a ton of information. Which run number was this? Basically, there's a ton of information that they give back to us. 99% of the time, you don't care about it. However, I just want to show you that it is accessible if you ever need to use it. So most of the time when you're using, these chat models, the main thing that you want to grab is the content, because the content is the example. So whenever we grab the result and we access the content property, we'll get back the exact string that we usually want to, show to our users or pull out and pass over to the next prompt in our, in our chat model. So that's under the hood how our first basic chat models are going to work. So what I would like to do next is we're going to go ahead and move over to the next example where we're going to start actually showing you guys how to do a basic conversation using our chat models to where we can actually pass in more information and actually having a full-on conversation. Let's go ahead and start working on this example now. All right, guys, so welcome to the second example where we're going to start focusing more on creating a conversation with our chat models. Now, the three new important concepts to know when going into this example are there are three different types of messages. In our case, that's going to be a system message, and a system message just sets like the broad context for the conversation. So these types of messages are usually something like, hey, you're a professional accountant, or hey, you are a professional Python software engineer. Help me write this code. So that's like just the broad what's going on inside the conversation, just the context. And then from there, there's two different types of messages. There are human messages, which is us talking to the AI, and then there's AI messages, which are the AI responding back to us. So those are the three types of messages that you can have in a conversation with the AI. Okay, cool. Now let's dive into the rest of this code so you can kind of see what's happening. And this is just, once again, we're building on our foundation. So we're just copying a lot of the code from the previous example, and now we're going to start building on top. In this case, we're going to start creating a conversation. So in our case, you can see a conversation is nothing more than we have our messages list, and our list is just going to store a combination and series of messages. In our case, we're just going to start off with a system message, and it's important. System messages, best practice, and I think it's actually enforced, a system message must come first. And then from there, you can alternate human AI. But system always comes first because remember, this is the context for the conversation as a whole. So in our case, we're going to say, hey, solve the math problem. And then from there, we can pass in a human message. And what we would expect to get back is obviously an AI message. So let's actually kind of see how we can actually trigger this conversation so we can get a result. So in this case, you'll see that we have once again, we have our model, our ChatGPT model, and we're going to call that important function that we talked about in the last one, which is invoke. But this time, we're not going to pass in a hard-coded string like we did over here, where you can see we passed in a hard-coded string. This time, we're actually going to pass in our entire message history, and it'll actually read through the entire conversation and then spit out a result. If you work with ChatGPT, it's exactly like that. If you've ever typed into the ChatGPT website, it's just like that. Okay, cool. So what we're going to do is we're going to go ahead, I'm going to comment this out. We're going to run the code so we can actually see what answer we get. So this time we're going to do Python. This is, still working with chat models, and this is example 2. So you can actually see whenever we get an example back with working with ChatGPT, it says, 81 divided by 9 is 9. So, that's exactly what we would expect to see. Okay, cool. But what's nice is we can continue this example and actually have a full-blown conversation. So I'll show you what that looks like now. So you can see in this second part, we actually have continued on the conversation by adding in AI responses and then human messages. So this case, we've added now like the response from the previous one, and now we're going to, just continue adding human messages. So I'm just going to run this so you can actually see what's going to happen. And this time it's going to come back and give us, 10 times 5. So this is completely basic. However, here's why chat conversations are super important. In the real world, when you're building your conversations, it's very common for you to provide an example of like, hey, ChatGPT or AI model, build me an email. It returns a response and then you provide feedback. Because remember, this is all about conversations. And what's going to happen is as you provide those, feedback of like, hey, no, make it less formal, make it a bulleted list. As you provide that feedback, what's nice is going forward in your conversation, you can say, okay, great. Now do exactly what you did for that last email, but now do it for this email. And, storing this message history like you have right here is how you're going to be able to basically make your chat models have awareness and context of what's good and what's bad and what's wrong. So this is a very powerful tool, and you'll actually use this a lot more whenever, you're working on bigger and larger projects. But okay, cool. Well, now that we have that under the hood and we actually understand just like basic conversations, let's keep it going and actually start working on actually exploring other alternatives for different chat models that we can use. Because right now we've been focusing on only OpenAI, but let's look at a few different examples of how we can use LangChain chat models, but with different, LLMs. So let's go ahead and start working on that now. All right, guys, so welcome to this third example where we're going to start exploring different alternatives of working with other models outside of OpenAI. So in this case, we're going to explore Google's Gemini models. We're going to look at Anthropic or Claude and look at OpenAI because I just want to show you guys how easy LangChain makes it to work with these different models. So let's scroll down so we can look and compare and contrast all the new code. So what you can see up top, this is exactly what we've been doing so far in all of our examples. We create our chat model. Once we have the model, we go off and invoke it, and then we get back some sort of result. Well, LangChain abstracts all the complexity away and makes it super easy to do the same thing with our Anthropic models and our Google Gemini models. All we do is instead of using the Chat OpenAI model like we've been doing in the past, we now just use Chat Anthropic. And then we can pass in whatever specific model within Claude that we want to use, just like we did with ChatGPT up here. And then we'll do the normal part where we just, go off and invoke it with our messages and get back a result. And it's the exact same thing for Google's Gemini models down here at the bottom. So LangChain makes it super easy to work with these different models. And this is very important as you build larger projects because certain models are much better at, at performing certain tasks. Some are cheaper, some are faster. So for different situations, you need to use different models. LangChain makes it super easy to do. And if you want to explore all the different models that each, Anthropic provides and Google provides, I have links for you guys. And just as an important reminder, if you want to go off and explore all the different chat models, back over here in our first example, back when we were working with the chat model documentation, you could start searching through here so you can explore all the different models and all the different functionalities that these different models provide. But okay, cool. Enough of that. Let's go ahead and start exploring our next example where we're going to be diving in and actually having a conversation with our user through the terminal. So let's go ahead and start working on this example now. All right, guys, welcome to the fourth chat model example where we're going to start actually having a real-time conversation with our AI models. This is going to feel just like the ChatGPT website, except it's running locally on our computer. So let's walk through how we're going to set this up. So the important part, per usual, we're going to create our chat model by loading all our environment variables and creating an instance of it. Now, here's where all the interesting part happens. Because we're having a conversation, we're going to create a chat history list, and this is going to store all our messages. So as we ask questions, we're going to add messages to the chat history. As the AI responds, we're going to add those messages to the chat history, and we're just going to continually keep adding all of our messages to this list. So here's how that works in this code example. So first off, the first message we're going to add is our system message, because if you remember, system messages are just general context for the conversation that's about to happen. So we're going to create that system message, and then we're going to add it to our chat history by calling .append on the chat history list. Cool. So now here's where all the core logic happens. So this is where our chat loop happens, and basically here's the core loop. We first ask our users, hey, what is the question or prompt that you have for the chat model? We're going to get back a query. So this is whatever the user passed to us. If the user gave us the keyword exit, we're just going to stop the conversation right then and there, and we're just going to print out the whole chat history. However, if they didn't give us the keyword exit, we're just going to have a full-on conversation. So what we're going to do is we're going to add the person's query as a human message, and we're going to add it to our chat history. Then what we're going to do is pass over that entire chat history list over to our model, like you can see right here, and then we're going to invoke it. So that model is going to then read all the messages in our chat history, get a response, and then we're going to print back that response to our user. And we're also going to, most importantly, track that response by, once again, updating our chat history. So we're going to update our chat history with an AI message because, this is the AI response. So enough talk. Let's go ahead and look at a code example so you guys can see this in action. So I'm going to once again open up our terminal, and I'm just going to call Python, and then this is our chat model project, and this is the 4th example. So now we can actually start running it, and per usual, it's now going to ask for a query. So I'm just going to ask it, who are you? So then what we'll do is we'll pass that question over to OpenAI. OpenAI will generate a response, and it actually prints it back to us. So this is exactly, if we're talking to ChatGPT on their website, this is exactly what it feels like. And we can actually ask questions about it because as a conversation, we can refer to previous messages. Can you expand on that? And what it'll do is it'll, because it can refer back to the previous messages and actually provide additional context. So this is super powerful, and you'll definitely be using this a lot more. And finally, we can pass in the word exit. It'll quit the conversation. And what's cool is you can see our entire message history here. So you could save this off somewhere. You could, save it locally, save it to the cloud, do whatever you want so that whenever the user comes back in the future, you can continue the conversation. And we'll actually do a much more deeper example later on where we actually save this to the cloud. So you'll learn about that in just a little bit. All right, cool. Enough of that. Let's go ahead and start working on our 5th example, which is exactly what I was talking about, where we're going to start saving our messages to the cloud. So let's go ahead and start working on this. We're going to save all of our messages over to Firebase. I think you're really going to love this one. All right, let's go ahead. All right, guys, welcome to the 5th chat model example. So this one is by far my favorite because you're going to learn how to save all the messages you type locally over to the cloud. And in this case, we're going to be saving everything to Firebase. So what I've done is I've actually typed out all the installation and steps for you guys because there's a little bit more background setup because we're working with the cloud. But once we knock out all the development setup in the cloud, what we'll do is just run through the code so you can see how everything works. But I think you'll see that all in all, this is actually pretty straightforward. The hard part is just setting everything up in the cloud. So let's go ahead and do that now. And the first thing I do want to mention about the cloud is this is actually based on this Google Firestore code base example. So you can see this is exactly what we're doing. However, I feel like they didn't do the best job walking through how to get it set up. And I struggled a ton the first time I did this. So I just want to share all the lessons learned that I have done, and I've copied all my lessons learned here. Okay, so the first thing that you need to do is create a Firebase account. So just head over to, console.firebase.google.com, and you're going to create an account. And once you've created an account, you're going to then go over here and create a project too. So I'm not going to walk through creating a project because it's super simple, but just go over here, click the drop down menu and click create a project. So that's how you create a project. Once you've done that, you'll then need to create, when you go over to the build tab, there's something called the Firestore database. And this is where we're going to be storing all of our messages inside of our chat history, except our chat history is now in the cloud. So whenever you click Firestore database, if it's the first time you're using the project, you're going to want to turn this on. So there'll just be a turn on button here for you. And you'll want to click that. And once you've done that and you run the code, eventually all of your messages and user sessions will get saved up to the cloud. And more on this later, but I just want to go ahead and paint a picture of where we're going. Fantastic. So once you've done that, let's head back to our examples. You'll need to start copying some information about your Firebase project. So what I mean by that is you need to start copying information such as the project ID. So in our case, what you'll do, come back over here, you're going to click the gear icon, you'll hit project settings, and this is where you'll find your project ID, project number, and everything that's, related to what you're doing with the project you just created over here in Firebase. Okay, cool. So that's the easy part. Now, this is where things get a little bit more complicated because we're trying to work with the cloud, so Google Cloud, and we're trying to have our local computer communicate with the cloud. So this is where we're gonna have to go a little bit deeper. So the first thing we're gonna have to do is install the Google Cloud command line interface on our computer, because what we're trying to do is authenticate our local computer to make requests to the backend. That's all we're trying to do. So what you'll do is, first thing, you'll click this link over here and it will take you to this. And this will basically just walk you through exactly what you need to type to install the Google Cloud CLI. It's super straightforward. You'll just click download. Once you've downloaded it, it literally walks you through step by step how to install it. So that's super, super easy. Then once you've gone through and installed everything and initialized it, the final part that we're going to do is you need to authenticate your local Google Cloud CLI to your account. So once again, click this link. It'll take you over here and it'll just walk you through how you can actually authenticate your local computer to Google Cloud, because we're just trying to create some default credentials. That way, whenever our code's running, it just can, seamlessly make a call to the backend. And the main things that you need to do, first off, just run Google Cloud auth, application default login, a sign in like normal Google Cloud sign in screen will pop up. You'll just log in. It'll make a service account for you. Life's fantastic. And then you'll run this, basically this script as well to finally get everything working. So I hope that's enough. I don't want to go too deep just because I want to focus more on LangChain, but run through those steps. You guys will be good to go. And then you'll finally have everything working inside your code. So, all right, enough of that. Here's how we're going to get things working over here. So you're now going to come in here because you have your project ID that you just copied. You're then going to have a session ID. So we're just going to make a new one. So we're going to call this user session new. This is where all of our messages are going to be saved. And then finally, there's a thing called a collection name. This is heading back over to Firebase, just the way our Firestore saves data. It's in a collection document, basically a database type. So you can see collection, document, collection. So it just keeps alternating. So we're going to store all of our messages in the chat history collection, and each session is going to be a document, and that document is just going to contain a list of messages. So that's what's about to happen. So what we need to do first off is we need to initialize our Firestore client. And what that's going to do is allow us with our client to go off and make requests. So that's why we're doing it. And then what we're going to do next is have something called Firestore chat message history. This is basically, we'll just click in here so you can see what's going on. But basically what we're trying to do is, in the past, you and I were storing all of our messages in a list. Well, LangChain has provided a bunch of different options for us to store all of the different ways that we can have and store our messages. So in this case, we're using Firestore to save our messages. There's a few different examples inside of LangChain where we can actually save our messages using, I think, the file message history class, where we can actually save all the messages locally on our computer. So there's a bunch of different options that I want you guys to be aware of, and feel free to explore through the LangChain documentation to see other options. But just know, at its core, all it's doing is just saving a list of messages, human messages, AI messages, back and forth, except now they're just being saved off to somewhere else. So that's what's happening under the hood, but let's keep going. So in our case, now that we've created our new chat history, except our new chat history is up in the cloud. So what we can do now is actually start running through the exact same loop that we did last time, which is where the human's going to ask a question. And now what we're going to do is just keep adding with our chat history. We're just going to add user messages, or we're going to add AI messages, and we're just going to go back and forth. So enough talking. Let's actually dive into the demo because this is super cool in my opinion. So we're going to go step by step because there's a lot of cool ways to show this off. So the first thing that we're going to do, let's clear this out, and we're just going to run Python. So we're in the chat models example, where this is the 5th example. Now what this will do is it'll start, initializing Firestore client. It'll start the chat message history. And usually this takes a few seconds to get started. And then now we can actually start chatting. So it's cool though, and you'll see this get populated in a second, our current chat history. Well, because this is the first time I created that new session ID, there's no history of this chat in the cloud. There's no user_session-new. So there's no messages to load. But now I can actually start talking about it. So I can say, who is Sam Altman? So it'll go off and answer questions. And so here's who Sam is. But what's super cool is if I come back over to the cloud, we can actually see our messages being stored in real time. You'll notice they're stored as byte strings, and they're not actual just plain text messages. That's just totally fine. That's how Firebase and Firestore are storing messages. But let's keep going. Does he have a brother? So we can keep asking, and then it'll say, yes, he has a brother. Here's his name. And then what we can do is exit it. So we'll exit. Okay, fantastic. All of our messages are cleared. You can see over here, we actually still have additional messages. But what's nice is whenever we restart this same file with the same, chat session, it'll actually say the current chat history, and it'll pull all of the different, messages that we have previously sent to the AI. So this is a super cool way, and I hope you guys are like, this is awesome. This is a super cool way for us to continue conversations at a later date without having to completely refresh from start. So I hope you guys thought this was awesome, because we can still, do additional stuff like, who was I just talking about? Let me fix this. Oh, sorry, wrong button. I can say, who are we just talking about? And then because this is a chat history, it can refer to the previous messages. So yeah, this is awesome. So I hope you guys are pumped. And that concludes the first module where we'll just run through all the different capabilities with working with chat models. And from here, we're going to move on to prompt templates next. So I do just want to point out before we keep going, if you have any questions, definitely hit that link down in the description below for Skool. Go over there and ask any questions you have, or hop on our weekly coaching calls. I'd love to help you guys out. But let's keep chugging along and start moving over to prompt templates. All right, guys, welcome to the second module in this LangChain crash course. This whole module is completely dedicated to prompt templates, and I think you'll find this is a super simple concept, but it's going to make our lives much easier as developers as we work with LangChain. So what the heck is a prompt template? Why does it matter? How does it work with chat models? So those are the main things we're going to be tackling in this module. So the first thing is prompt templates. The best way to think of them is exactly what the name says. We are building up a prompt. That's our whole goal. We're trying to create a prompt, but we've created some sort of template like this, and it's up to us to pass in values into that template. So, kind of think of like fill in the blank is the best way to describe it. So, you could do generate 3 jokes about dogs or something like that is kind of what we're shooting for here. So enough like high level. Let's actually dive into like what this actually looks like in action as like a quick overview. And then after this, we'll dive into the code. Okay, so like I said, our whole goal is we're striving to generate a prompt, but we're going to be passing in some variables to make this work. So, we're going to be taking like a user response to help us really fill out this prompt. And this is important because eventually these prompts are going to get passed over to our chat models to perform some action. So in our case, like this is a joke template. So eventually this template, once it gets populated, it's going to get passed over to, ChatGPT or Claude, one of those models, and it's actually going to spit out some jokes for us. So that's just, this prompt is going to help us structure the prompt that we pass over. So it's super helpful. We'll dive into some more examples here in just a second, but this is exactly how it works. It's up to you as whenever you're creating these prompts to basically create a string, and inside that string, it's up to you to use these curly brackets to create variables. These variables are later going to be populated with these values. And what's important to notice here is once we've created our prompt template, we're going to define an input dictionary. And this input dictionary is going to define for each one of these variables the values that are going to replace them. Because eventually, whenever we have our template, pass in these inputs and call invoke, because remember, invoke is the super magic word for all of LangChain. What it's going to do is it's going to basically do some string interpolation and replace all of these values so that we end up with an output that looks just like this. Obviously, this was a super simple example, but let's just think like higher level, like for a real world setting. You could eventually be creating some sort of tool that helps developer automatically debug their code. Well, in your case, you would create a prompt template that's like, here is the user's code, and then, you would have user's code. Here's the error they're getting. That would be the next variable. Please help them debug this. And then basically you would pass in that entire prompt filled with the user's code and error over to OpenAI, and then OpenAI would tell you, oh, it looks like here's the bug, here's how I'd fix it. So this is just a really nice way for us to create structured prompts that make it easy, where we can do some prompt engineering and easily add in our users' input to the prompt templates that we're creating. So enough jargon. Let's actually dive into an example and start walking through our first example working with prompt templates. And I think this will make a ton of sense and it'll be super easy to understand. All right, guys, so let's go ahead and dive into the code. And this one's going to be a super simple code walkthrough. There's 3 parts to this, and then I have one little extra part so you guys can see, when not to use prompt templates. But let's walk through this part by part just so you understand everything at a basic level, and then we'll work our way up from there. Okay, so if you remember, our whole goal is we're trying to create prompts that we could eventually pass over to our chat models. So we're focusing in on creating prompt templates. That's all we're trying to do. So let's go part by part in this code. And what we're going to be trying to do is trying to relate it back to this outline that we have over here. So the first thing we need to do is create a prompt template that stores our variables of things we want to replace. So that's exactly what we're doing right here in this code. We're creating a template, which is just a string. And what we're going to do is we're going to call chat prompt template. And well, what the heck is this? Well, if you remember at a high level, we're eventually trying to, our end goal is we just talked about chat models. That's all we were just talking about in module 1. Well, what we're trying to do is create prompts that we could eventually pass over to those chat models so that, AI can basically answer whatever questions or ask that we're putting together in our prompts. So that's our end goal. So what this chat prompt template does, what it's trying to do is it converts our string into a template that makes it easy to work with to actually replace, basically replace all these variables with these values. So that's basically what's happening under the hood. So once we create this prompt template, so once we have our template, what we're trying to do is we want to pass in an input dictionary that has all of our keys and values. So that's basically exactly what was happening right here. And what we're trying to do is, once again, we're calling that magical word invoke. So in this case, what's going to happen under the hood is we have this prompt template. We're going to call invoke with these specific values, and all it's going to do is it's going to go through each variable and replace it with the appropriate value. So let's go ahead and run this code so you can see it in action. So in our case, we're going to do Python, and now we're in prompt templates, and we're going to run the first example. So 2, 1. And what this will do is now when I run it, what you'll notice is it actually doesn't spit out a string. It actually spits out a human message. So tell me a joke about cats. So that's pretty cool. It actually filled in the values that we told it to. And if you remember, what it did is it spit out basically a messages array that we could eventually pass over to our chat models, because that's where we're trying to go. So that was a super simple example. One of the other things I want to show you in this is we can actually, instead of just replacing one value, let's go ahead and look at part 2. What you'll notice in this one is we can actually replace multiple values in a prompt template. So this is the exact same thing, except this time what we're doing is replacing multiple values. So let's go ahead and yeah, we're still calling the same chat prompt template from template. So let's go ahead and run the same example again, just so you can see it in action. So yeah, running with multiple placeholders. This time, tell me a funny story about a panda. That's exactly what happens. Okay, enough of the simple examples. Let's actually get on to some more of the cooler parts, which is part 3. So if you've seen so far, every time it's created something, it has basically been from a human message point of view. But sometimes you actually want to do a little bit more, you want to have a little bit more control. So what you'll notice in part 3 is we can actually start defining, basically, we can specify the types of messages we want to create. And not only what type of message we want to create, we can actually still, replace all the variables in here. And what you might notice, and which I thought was weird the first time I used it, I would have expected that, what the heck is this like tuple where the first part's a simple, the system and then the message, then we have another human, then message. Like, why aren't we just using like human messages and system messages? Well, it all comes back to the way the chat prompt template works, is it just expects this tuple format where you define the message type first and then the content. So just know if you want to basically use prompt templates and also define the message type, you have to go with this tuple approach. But yeah, let's go ahead and see in action so you can see exactly what it looks like. So we're running part 3. So we're just going to run the code again. So you can see now we have a list of messages, and the first message in this array is going to be a system message. And you're a comedian who tells jokes about lawyers, so that's setting the context. And then you can say, tell me 3 jokes. So we actually just replaced the variables there too. So yeah, so once again, we've created these messages, and we could actually pass this message list over to our chat models, and it would spit out those jokes about lawyers. Okay, now I just want to show you, this is just a lesson learned that I thought was pretty interesting. So if we come down here to the final part, what you'll notice, I'm just going to comment this out so you can see it. So this code does work. So you know how we just talked about tuples? Well, anywhere you want to do string interpolation, where we're replacing values, you have to use the tuples. So you'll notice we want to replace topic in this system's tuple. So we have to put it in a tuple. And then, well, for the human message, we're not doing any interpolation there. So we're just going to leave it how it is. So this example would 100% work. So let's clear it out. And I'm just going to show you it works. So this one works. Yep, it looks just like we talked about in the first example. Well, if you come down here to the final example that I have in this file, you'll notice I say this does not work. And basically what we're doing here is we're trying to do interpolation on a human message. So let me just show you what happens when you try and, like, if you don't use a tuple, you'll basically get, you'll basically notice here, tell me a joke, and it never did the replacing part. I ran into a lot of issues when I first started using LangChain and doing prompt template replacements. And I was like, why isn't it replacing it? And it's like, oh, it has to be in this tuple format. Okay, hopefully that's enough prompt templates, like basics. Let's actually start moving on to the next part where we're going to start using these prompt templates with a chat model in our second example. So let's go ahead and start working on that now. All right, so welcome to the second prompt template example. This one, we're actually going to tie together everything from module 1, which is creating our chat models, and everything we just learned about prompt templates. So let's go ahead and merge both these together in the example so you'll actually really understand the whole value of creating these different prompt templates. Okay, so per usual, like we did in all of module 1, we're going to load our environment variables, and we're going to go ahead and create a chat model that's using OpenAI in this case. Now, let's go part by part so you can actually see the exact same, basically all the prompt templates that we created in demo part 1. We're actually now just going to not only create those prompt templates, but we're actually going to pass over those prompts to our model. So let's look at example 1 in depth, and then we'll just run it, for everything else. So per usual, we're going to create our template with the variable we want to replace. Once we have that string template, we're going to call chat prompt template, and we're going to make an actual template from that string, just so it's easy for LangChain to actually start manipulating it. And then from there, we're going to do exactly what we did last time, which is call invoke, because that's the magic word for our prompt templates to take in that string and actually start replacing all the values. So once we call invoke, we're going to get back that prompt. And what's cool is we can now pass that prompt, which is, if you remember from the last one, it's now just going to be a message array that has all of these values in here. So, it'll say, tell me a joke about cat. And that'll be one of the messages in our message history that we're going to pass to our model. I hope that makes sense. Whenever I run it, it'll actually make more sense. So, but what you can see is we're now going to pass that prompt over to our model, and we're going to tell our model invoke, because we want our model to actually perform actions on these messages, and we're going to print the result. So you'll start to see, invoke is going to get called a lot as you start to work with LangChain more and more. And I'm not going to go too deep in part 2 and part 3 because we just copied and pasted over all the examples from the last time. And now we're just actually going to let AI actually basically run the request, which is creating jokes about all these different prompts we've created. So what we're going to do, call Python example 2, and this is the second example for prompt templates with a chat model. Let's go ahead and run that. And this will take a few different examples, seconds, but you can see, so prompt from a single template, which was right here. Tell me a joke about cats. So, sure, here's a joke about cats for you. Why was the cat sitting on the computer? Because I wanted to keep an eye on the mouse. So obviously they're pretty corny. And same with multiple placeholders. So it actually told a short story about, a short funny story about pandas. So here's our funny short story. And then finally, when it comes to the end, where we're doing, prompts with system and human messages, what we're doing is creating 3 jokes about lawyers, and that's exactly what it did. Here are your 3 lawyer jokes. So why don't sharks attack lawyers? Because of professional courtesy. So once again, pretty corny, but yeah. So I wanted you guys to see prompts with prompt templates, because right now we're calling invoke to get the prompt. We're calling invoke again to get the result, which leads us perfectly to chains, because this is exactly what we're about to do next, where we're actually technically we're chaining prompts with chat models. So this will make more sense. So we've set ourselves up perfectly to dive into section 3, which is all about chains. So let's go ahead and start diving into that model now, and this will all make sense, and it'll actually be a lot simpler. So you'll see what I mean in just a second. All right, guys, so welcome to the 3rd module in this LangChain crash course. This chain section is by far my favorite part of the whole tutorial, and I hope you guys love it just as much as I do. So let's walk through what the heck is a chain, why is it important, and then just go through a few different examples real quick, and then we'll hop over to the code. Okay, so at a high level, what the heck is a chain? Well, inside of LangChain, it's nothing more than tying together a series of tasks. So if you remember, so far we've been using .invoke, the invoke function, a lot. So we've been using it to create prompts. We've been using it to basically have chat models respond to us. So what we could do instead is have the prompt be chained, like the output of a prompt, whenever we invoke it, that output be fed to the model. And then that model, whenever we call invoke again, it will spit its outputs, and it could just go to the next item. So as you can see, we're kind of just chaining together different tasks, and we're passing the input from the first one over to the next one. And we just keep going down and down and down. So that's exactly what's happening right here. Have a prompt, invoke it, spit the outputs over to the next thing. Take in those inputs, process it with invoke, and then spit it out to the next thing. So that's exactly what's happening with chains. And I think you'll think when you see the code, it's super simple. And there's another common thing when you're using chains inside of LangChain, and it's called LangChain expression language. It's a fancy way to say and describe how you can create chains, because you can go the hardcore code way, which we're not going to get into. We're going to stick to this, which is just anytime you want to chain items together in LangChain, you're going to use the pipe operator. So this is right above your return key on your keyboard. It's just the straight up and down, basically pipe key. So that's how you're going to create a chain. You're just going to put, a prompt, a chat model, and there's a few other things you could put in here too, but this is how you're going to do it. Item or a task, a pipe operator, another task, a pipe operator, another task. Super easy to set up. And then whenever you want to run the chain, all you do is you call the chain and you call invoke on it, and then you pass in your input dictionary of all your different keys and values. This actually should be a quick, my bad. This should just be a quick dictionary, just like this. And that's how it works. So this initial key dictionary gets passed in over here as the first into the first prompt, then it gets passed along all the way through. So that's just at a high level, just a simple chain. Now I just want to show you the realm of the possibilities when it comes to LangChain first, and then we'll hop into the code. Okay, so when it comes to chain possibilities, the first thing to know is you don't have to do just prompt chat model. You can actually keep going. So you can just continually keep going as long as you want. That's option 1. The other thing that's super cool is you can run task in parallel. So you can have task, just kick off, and you can just start running your chains in parallel. And then you could actually, even at the end of them, you can actually join them together and have your final results all come back and be fed into one. So this is a cool way just to, like, if you need to do some parallel processing, this is a cool way to do that. The final thing is branching. So branching is a way inside of your chains to have it to go like, let's, at this node, let's kick off some actions. Cool. Well, based on the results of those actions, let's just say like, oh, if we're doing a review of a movie, well, if the movie was good, cool, we're going to go down this branch and this chain path. If the movie was awful, we're going to go down this path. And if it was so-so, we're going to go down path C. So that's just kind of like the realm of the possibility when it comes to chains, but enough like theoretical high-level stuff. Let's actually dive into the code and start working on the simple model first, and then we'll work our way up through all the different possibilities. So let's go ahead and dive into the code. All right, everybody, welcome to the first code example when it comes to chains. I think once you see how this all works, you're going to be like, oh my gosh, this is so much easier than what we were doing beforehand. And what's cool is we're going to use basically the same examples that we did from beforehand, but just reformat them so they work with chains. So let's go ahead and dive through this and walk through it step by step. So the first thing that you notice, we're in the chain basics file. What we're going to do is exactly what we've been doing so far with everything else. We're going to create our chat model. Once we create our chat model, we're going to create our prompt template. Our prompt template is going to contain our variables that we want to replace. In this case, it's going to be the topic and the joke count. From there, what we're going to do is create our chain. Now, what you'll notice, this is very similar to the drawings I just created a few seconds ago. The first thing we're going to do is have our prompt template, which is going to contain all the messages that we want to basically replace with our inputs later on, create our prompt. From there, we're going to pass that prompt to our model. Once our model then is able to process that prompt, what we're going to do eventually is spit everything out to a string parser. At first, I'm going to get rid of this string parser just so you can see why we need it. But just know at a high level, all it does is it takes, how so far every time we get the result, we do .content. Well, that's exactly what the string parser does for us. It just goes ahead and grab the content. But we'll add it back in a little bit. So I'll comment it out just so you guys can see it, how it works. Okay, cool. So what I'm gonna do is go ahead and run this chain just so you guys can see how easy it works and how simple it is, and how much less code we're doing in this approach versus what we were doing last time. So what I'm gonna do is go ahead and open up our terminal. And then if you remember now, we're in the third module because we're working with chains, and this is the basic example. So we're just gonna run Python 3 so we can go open our chains file, and this is the first example. And what I would expect to see is once we print the result, we're going to get that long response that we normally get whenever we don't grab the content. So you can see, yep, here are, whenever we look at the content, you can see, yep, here's the 3 lawyer jokes. And then we're seeing all that extra information that we get back from our LLM, like tokens and so forth. But if we undo our changes earlier and just use the string parser that you can see right here, where we're just doing the string output parser, this also comes from, we'll talk about this more, but the output parser library, that's where it's coming from. But if we rerun it now, what you'll notice is it actually just spits out the final text. Like this is what we would actually expect to return to our customers if this was a web app, or this is what we would like most likely pass to the next model if we were doing this, and continuing the chain. So this is awesome. I hope you guys see how much easier this is to use compared to what we were doing last time. Let's just do a side by side so you guys can kind of see exactly what this looks like. So over here, what we were doing, at the bottom, we had our, we created our prompt templates, then we did our prompt, then we invoked it. Then after we were done invoking it, we saved the result, then passed it to our model, then did it again and again. So all of this code right here, basically, just gets replaced with this single one line, which is beautiful. So I hope you guys like this. So now that we understand the basics, what I want to do is we're going to dive deep for a second in the next example, where we're going to understand how chains work under the hood. And after we do that, we're going to start building off those examples you saw earlier, where we're going to do, parallel, chains, and then branching and much more. So let's go ahead and dive into the next example. All right, so welcome to the second example in the chains module. And in this example, what we're going to do is a deep dive into how chains work under the hood. Now, this isn't super important for you to like memorize or understand exactly how everything works under the hood. It's just I want you to be aware of a few concepts such as runnable sequences, runnables, and runnable lambdas. Those are the main 3 things that we're going to talk about in this section. Okay, so let's dive into the code and we'll look around. So per usual, what we're doing is we're creating our models and loading our environment variables, creating our prompts. And then most of the new action when it comes to creating basically chains the manual way happens right here. So what we're going to do is talk about this at a high level, and then we're going to dive into each part. So at a high level, what we're doing is we are creating runnable lambdas. So think of a runnable is a task. Whenever I was talking about task in the initial outline for chains, under the hood, the way it actually works in LangChain is it's just called a runnable. So what we're doing, a runnable lambda is nothing more than a task that's a lambda function. And if you're newer to Python, don't worry about this. Lambda functions kind of get like a little bit more into weeds, but they're just a quick way to make functions. Like here's the input to a function, and then here's the actions we want to take. So that's just kind of what lambda functions are. So that's part one. Part two is this thing called a runnable sequence. And a runnable sequence is nothing more than we're going to do this task, then this task, and this task, then this task. And put all those tasks together, you have a sequence, aka a runnable sequence, aka a chain. So that's exactly what's happening. So let's actually dive in deeper into these runnable lambdas and runnable sequence so you can actually see what the heck's going on. So the first thing is what we're going to do is we're going to create the format prompt runnable lambda. And what this is going to do is all it's going to do is take in our prompt template that we've done in the past. And then instead of calling invoke on it, what we're going to do is just call the format prompt. And the format prompt is basically just going to like, yep, replace all these, values right here with these values down here. So that's exactly what's happening under the hood. And you can see we're passing all of our arguments and spreading them right here. That's exactly what that's doing. Basically, we're just passing this dictionary and spreading it so that we can replace all these key values with these values down here. So that's what's happening. Don't have to understand how it works exactly. I just want you to be aware of like what's happening. From there, once we have our prompt and we've created that task, we're going to create an invoke model task. And the whole point of this runnable lambda, once again, is just a task that takes in a lambda function. All this is going to do is it's going to say, yep, we have a model. We're going to invoke the model. And what we're going to do is pass in the input from the previous function into this one. And we're going to convert whatever the heck we just received to messages. So that's what's exactly happening there. Finally, we're going to parse the output. So if you remember the string output parser, well, under the hood, all it's doing was grabbing the content from the output, and that's what we're going to do right here. So here's how, now that we have all these individual runnables, here's how it works with a sequence. And let me just show you under the hood what a sequence looks like. So just in case you haven't seen this, if you have a Mac, you can hit Command and click basically any class, and it'll take you to the definition. If you have a Windows, just hit Control and then click the class, and it'll take you to basically the definition. But basically, this is recapping everything that we have just talked about. A runnable is nothing more than just like it takes the output from one, passes it to the next as an input. So we're really just creating a sequence of tasks that need to occur. They give us a cool little example just to show us like, yes, whenever we use LangChain expression language to where we just like pipe task and runnables together, it's actually the same thing as, calling runnable sequence first and last. And then once you have a sequence, you can invoke it and pass items into it. So that's what's happening under the hood. So let's actually hop back to our code example and finish this one up real quick so we can actually keep going down the chain. What you'll notice is whenever I created my runnable sequence, you'll have 3 different properties that you can call. And this is because if you scroll down to the actual code part, you can see there's 3 different things. There's first, middle, and last. First is a single runnable, last is a single runnable, and middle is a list. So that's just how you have to pass in your sequence. So if you have 2 items, you'll call first and last. If you have 5 items, 10 items, 100, you'll have to call first for the first item, last for the 100th, and everything in between will just get passed in as a list. So that's exactly what's happening. So in our case, the format prompt, where we convert our text over to a prompt, happens as the first task. Our middle task, where we have our formatted prompt and pass it to our model so we can actually process it, that gets passed in the middle list. And then finally, for the last thing, once we have our prompt, pass it to our model, process it in AI, and we just want to get that final text output, well, that's why we're going to call the last runnable task, which is just going to be parts output. And when you put all that together, you end up getting a chain, and that chain is we'll call it the exact same way that we were doing earlier. So what I'm going to do, I'm going to run the code real fast just so you can see how it works, and then I'm going to compare them side by side just so you can see like that's crazy that they do the same thing, but this just takes so much more work because we're not using the LangChain expression language. So this is chains under the hood. So we're going to run it. And as you can see, whenever it finally gets done, it's just going to spit out a response, which is, just 3 jokes about lawyers. So yeah, that's 3 different jokes. And just to show you a quick side-by-side, let's go open up 3.1 chain basics and zoom out. Yeah, so instead of doing all this nonsense where we're creating runnable lambdas and passing stuff over and over and creating runnable sequence, just stick to LangChain expression language and it just works. So I hope you guys now understand why LangChain expression language is so nice, and that's probably what you'll use 99% of the time whenever you're working with building chains. But enough of that, going deep, let's actually hop back up and start working on some of the additional ways we can use chains. So we're gonna broaden them out in the extended section, and then we'll keep moving on from there. So let's go ahead and hop over to part number 3. All right, guys, so welcome to the third example in the chain module. And in this example, we're going to showcase how you can continually extend your chains and add on additional runnables, or probably the easier way to think of it is additional tasks to continually happen, and you can just keep growing that chain forever. So let's just go ahead and look at the code in this example so you can see how it actually works. So what we're going to do is the per usual, where we're going to load our environment variables, then we're going to create our model, and then we're going to create our prompt. That's all the usual stuff. All of the new chain extending happens right here, where we're going to uppercase the output and then we're going to count words. So let's actually dive into what's happening. Well, what we're going to notice is we're creating our usual chain, and then we've piped in an uppercase output. Well, under the hood, when we actually look at what's going on in this function, because it is important whenever you extend or add new items to your chain by doing the pipe operator, you need to add runnables. That was one of the key things we talked about in the under the hood section. So in this case, we're going to add a runnable lambda. And runnable lambdas just make it super easy to basically process any type of function. So in our case, we're just going to do some string manipulation where we're going to uppercase, sorry, I'll slow down for you guys, but we're going to take in an input, and what we're going to do is call .upper on it, which is going to capitalize the entire output. So that's what's happening under the hood. But what's cool with runnable lambda functions is you could also use these to go off and make an API call. You could, you could really do anything that you normally could do with Python code. You could just throw it in a runnable lambda function. So that's the part that makes this really cool. But so now that we have uppercase the output, what we're going to do is continue building on our chain, and we're going to pipe the output of this over to count words. So in this case, when we come look at our count words runnable lambda, you can see we're going to take in an input. This input is going to return basically a string that we're going to do some interpolation on, which basically just means some formatting and passing in values. So the first thing we're going to do is count the word count. So what you can see is we're going to split the input that's given to us. And then once we're done with that, we're going to count how long the actual input was. And then once we're done with that, we're just going to spit out, right here where it just says, curly brackets X. That's where we're just going to print out the input that was given to us. Enough talk, let's actually dive in so you can look at what actually happens under the hood when we actually run this. So this is the third module for chains. This is the third example. And when we spit it out, we would expect to see the word count. Yep, just like that. And then jokes. So as you can see, this code ran perfectly. We spit out the output, and you can actually see that this code ran too because everything is capitalized where it wasn't originally. So this is how you can continually build chains, and as you're going off and becoming, a real world professional LangChain developer, some of the other practical things you would do is just, like I said, you would use runnable lambdas to go off and create API calls to go do something. You would then, there's just a ton of stuff that you could do, and chains make it super easy to, pipe an input from the previous result over to your current function and just continue going down the chain. So this is awesome. So now that we've covered extending and continually growing your chain, let's hop over to talk about how you can actually run chains in parallel. I think you're really going to like this section too. All right, guys, so welcome to the fourth example in the chain module. In this code, what we're going to be doing is showing off how you can run chains in parallel. So I think this one's super cool because if you've ever thought about creating social media posts where you have an idea and then you want to branch off to write something on LinkedIn and then Twitter and then elsewhere, this is exactly how you're going to go about doing it. So let's go ahead and dive into the code at a high level, and then I have a visual for you guys just because it is a little bit weirder to see how it all works, and then we'll come back to the code to really dive in. Okay, so at a high level, this file is a little bit longer, and I'm just going to hop down to the chain part, and then from there we're going to go over to the visual I was just talking about. So at a high level, what you can do is you can see we are creating a chain. This chain has the usual prompt, has a model, we do some string outputting, and then we start doing this funny thing called runnable parallel. Under the hood, basically what this is doing is it's creating different branches to run, if we're looking at pros, because this is going to be a pro-con list, and we're just going to run our pros in one chain, and we're going to run our cons in another chain, and eventually merge those pro-cons into a final list. So that's why we have two branches, one for a pro branch, and then a con branch. and that's where they're going to go off and generate pros and cons, and we're going to come back and put it into a final list. So that was high level, just talking through the code. So let's hop back over to what this looks like under the hood when we're actually like, visually, what does this look like? So that chain that we were just looking at, what we're going to do is going to take in a prompt. This prompt is going to take in a product name. From there, it's going to construct a prompt using, in our case, I think we're going to do the MacBook Pro. And then from there, it's up to the model to produce a list of features about that product. From there, we're going to grab the content like we normally do from the result from the model and just pull out the content string. And what's cool is we're going to pass that string to our two separate chains. So I don't know if you saw back over a second ago, but we had a pro chain and a con chain. That's exactly what we're doing here. So the pros, it's going to take in, the list of features. In our case, we're going to pull out all the pros from those features. And then what we're going to do on the other side in parallel is find all the cons for all of those features. And then finally, once we're done with both of those different chains that are running in parallel, we're going to grab both of the outputs and then put them together in a final Lambda runnable. So we're going to get both of those outputs and then put them in basically a nice print statement for our users to read pretty easily. So that's exactly what we're doing. Now let's hop back to the code and do a deeper dive. Now you have a good understanding of like what's happening at a super high level visually. All right, let's hop back. Okay, let's dive into this part by part. And I think the best way to go about it is just start, at the first item in each chain and then walk our way through. So when it comes to the prompt template, this is where we're going to be doing our normal prompt template stuff, meaning, we're just going to say like, hey, you're an expert on doing product reviews, and I need you to basically list the main features for this product. We're going to create a prompt for it. In our case, like I said, this is going to be a MacBook Pro, and then we're going to pass that prompt over to our model, who's going to go off and actually list those features out. Then we're going to do our string output parser. None of this should be new so far, but then we're going to hop into this runnable parallel. Basically, runnables are how chains work under the hood. So in this case, we're doing parallel, meaning we have a bunch of branches that we can spin off our different chains. So in this case, we're going to have a pro branch and a cons branch. And you can actually dive in and see what each one of these are. So this pros branch, under the hood, it's a runnable Lambda. And what we're doing is we're actually just creating, in our case, we're creating a new chain right here. That's exactly what it is. I can actually rename it for you guys so you can actually see exactly what it is. We'll call this one a chain, that one a chain. Perfect. Just so it makes a lot more sense and it's even more clear what's actually happening. So we're creating a chain for our pro branch. In this case, we're just saying like, hey, take in the input, which in this case is a feature list. I want you to analyze those pros. So analyze pros, all it does is it creates a new prompt template, just like we normally do. And once we have that prompt template, what we do is we pass that prompt template over to our model for our model to go off and generate those pros. And then finally, per usual, we use the string output parser to convert that output into a nice string. And the con branch is the exact same thing. We take in that list of features about our product. We pass that list of features over to this prompt template. So, given these features, list the cons of each one of those features. From there, pass it over to our model, string output. So all this is completely normal. We've done this a ton of times. Now here's what's different. After we run our parallel branches, what we end up with is actually one big dictionary. And that dictionary, if we'll print it out, I'll print it out for you guys so you can actually see what I'm talking about right here. So we'll say final output. What you can see is it'll actually include something called branches. And this branches will, under the hood, actually list out our pros and cons because that's how we're going to save them. And you'll see it in a second whenever I print it out. But that's the final part. What we're going to do is pass in our pro output and our con output into this combined pros con function. And what this is going to do is just print out a nice list string final output for us. So we can compare like, yep, should we get the Mac? Should we not get the Mac? So let's run it and actually dive into the outputs. So let's go down in here. Let's clear all old outputs up and start running it. Now what's going to do under the hood, like I said, it's going to start running. And the first print output we should see is this final output right here, where we're going to have our pros chain and our cons chain. We're going to be able to view both of them. That's what's going to happen in here. And then finally afterwards, we should expect another final output. I just want to show you guys under the hood how the inputs are getting passed into this and how we can actually view like, yeah, it does make sense that we need to grab the branches object. And then within the branches object, we need to grab the pros and cons. So let's scroll up so you guys can see exactly what I'm talking about. Takes a few seconds. Okay, cool. So here's where everything's in a dictionary. That's why it's all cluttered to see. But you can see final output. What it does, you can see it's a dictionary. Inside the dictionary, you can see the first object inside of it is called branches. And then within branches, we can grab pros. And then if you scroll down a little bit later, you can also see cons. If I just search for it, you'll be able to see it. cons. Let's see. Yeah, so you can see here's the cons object. So how does this actually work under the hood? Well, it's because everything in this runnable parallel is equal to, we basically created a dictionary right here, because you can see we have branches is equal to, and then we were creating our object. So pros are going to be saved as the result of this pro chain, and cons are going to come from this con chain. So that's exactly how it works. So I hope that makes sense. Once again, this is getting a little bit deeper into the weeds when it comes to working with LangChain, and we're starting to do a little bit more like fanciness with Python. So if you have any questions on any of this, please definitely go over to the Skool community that I've created for you guys. Drop a comment, take a screenshot of what's confusing you, and I'd be happy to help, or hop on our weekly coaching calls. But I hope you guys see the value in this, because in the past you would have had to run your pros chain, that would have taken 30 seconds. Then you had to run your cons chain, that would take another 30 seconds. But now when we can run stuff in parallel, we can cut it down and make things a lot more efficient. If you're going to be building applications for your users where they're expecting a speedy output, this is exactly what you're going to want to do to help automate and speed up some of your tasks. All right, so enough of talking about running chains in parallel. Let's go over to learning how we can start branching our chains based on different conditions. Let's go ahead and dive into task number 5 next. See y'all. All right, guys, so welcome to the 5th example in the chain module. In this final example, what we're going to do is cover branching. And I think the best way to cover this topic before diving into the code is to actually look at what this code looks like visually. So let's hop back over here to Excalidraw and let me run you through what's actually happening under the hood. So there are 2 parts to this chain. The first part is what we're going to call the classification chain. And what we're trying to do is we're trying to take in feedback from our customers. So they're going to say like, man, that was awesome. Or like, oh, that was the worst product I ever bought. And depending on what type of feedback they give us, we're going to have different prompts to generate different types of messages. So we're going to have a positive branch, we're going to have a negative branch, a neutral branch, and then if something goes wrong, we're going to have an escalation branch. So here's a quick run through of what's happening visually, and then we'll hop back over to the code. So visually, what we're going to do is do the normal chain for our classification, where we're going to have a feedback prompt. What we're going to do is in this prompt, we're obviously going to populate the prompt with the user's input. In this case, it's going to be their feedback about what we're doing. Then we're going to categorize that feedback into one of these 4 keywords: positive, neutral, negative, or escalate. So that's how we're going to basically classify everything. Then we're going to pull out the category with a string parser like we've done a ton of times by now. And here's where the new concept comes in. It's going to be called a runnable branch. And basically the way this works is think of it as like an if statement. So if a condition's met, we're going to run a different chain. So this is a really good way to really make your chains more intelligent, and in different scenarios run different chains. So in this case, just going deeper, we're going to check if the category was positive. If it was, fantastic, we're going to run the positive chain. Was it negative? Cool, we'll run the negative chain. So forth and so forth. So I hope this all makes sense. Now let's hop back over to the code so you can see what this actually looks like inside of LangChain. All right, so welcome back to the code, and I think what you'll notice is this is going to be super straightforward. So what we have to start is we have a bunch of different prompt templates. Each one of these prompt templates for positive feedback, negative feedback, neutral feedback, and escalate feedback, all these different prompt templates come from right here. So as you can see across the board, we have all these different prompts. That's what we're doing. We're building up each one of these chains for the different types of feedback. All right, let's keep going. Then eventually what we're going to do is we also need to create the prompts for our classification part. So this is, how, your helpful assistant help us classify the sentiment of this feedback. Is it positive, negative, neutral, or do we need to escalate it? And this is how we're, using our prompts to pass in our users' feedback. Cool. So here's where we're going to get into the new part, which is the runnable branch. So this is the part that is different than anything you've seen so far. So what you're going to do is you're going to create a runnable branch. And the synopsis of how this works is you're going to have a input. So in this case, we're just going to use the lambda function. And then you have a conditional right here. So in this case, we're going to say like, hey, is the word positive in the input that you just gave me? If so, fantastic. I'm going to run, and this is basically, this is basically the positive chain. I'll just write right here, back chain. Fantastic. So this is actually what's happening under the hood. We didn't full out, call each one of these their own chains, but each one of these is a neutral chain, a positive chain, and a negative chain. So here's, this, because this is, once again, we're using LangChain expression language to create a positive chain. So as you can see, we're just going to take in the prompt template that we saw above. We're going to pass that to a model, and then we're going to get back the output. So this is a message that we could respond to our users saying like, oh, You loved our product? Fantastic. I really appreciate it. And we hope you, continue to buy further products and services from us. Okay, so now you've kind of seen how we're going to use runnable branches to conditionally run different chains, such as positive chains. Check to see if it's negative to run the negative chain, see if it's neutral to run the negative chain. The other part that I haven't mentioned yet is there's a default. So when you're using runnable branches, if any of these messages didn't trigger off, like if we didn't run, the positive, negative, or neutral, you basically can create a default branch. And in this case, we're going to call it the escalate branch. And what this one's going to do is it's actually just going to make a nice message for us that we can see where it's going to say, hey, generate a message to escalate this to a human agent. So that's just kind of how it works. And this could definitely be super helpful in a customer service type of situation. So I just wanted to show you guys this because it's super helpful and helps you build more complex tools. All right, so now that we got the runnable branches out of the way, let's go back to see how we can make this work. So basically in the end, we're going to have our classification chain and then, which is just going to be this whole part right here. This is the entire classification chain right here. And then the entire bottom part, all of this huge square right here is going to be this second chain. So we're chaining chains together to make super long, complicated ones. I hope you guys like this. All right, so what we're going to do next is I'm just going to go ahead and run it so you guys can see the results. And if you want to play around with this code for yourself, what you'll notice is I went ahead and typed up a bunch of different types of reviews so you can experiment with each of the different branch paths. So let's go ahead and run it for a positive review fast, just so you can see, how it works. So we're just going to go open up our terminal. And this time what we're going to do, we're going to do Python. And this is the third module, so chains 5 to run this branching program. So we're going to run it. And what we would expect to happen is it to go down the positive branching path and generate a nice positive message. So you can see, I hope this finds you well. I just want to personally thank you for your positive feedback. So you can see it's actually working. And what we could do too, if you want to try out something different, let's try out a bad review just so you can kind of see how it would go down in this case, go down the negative branching path. So I replaced it with the negative comment. It's terrible. I broke it after just one use. And then you can run it again. So let's see, thank you for your feedback. I'm sorry that your experience was not up to your expectations. We take all this feedback. So as you can see, this is a way we can handle a bunch of different scenarios using LangChain expression. So, but yeah, that concludes the third module where we're covering chains. And what we're going to do next is move over to RAG, which is going to be where we're learning about retrieval augmented generation. This is going to be a huge module. I hope you guys are pumped for it. Let's go ahead and dive into it now. All right, guys, welcome to module number 4, where we're going to start learning about retrieval augmented generation, also known as RAG. So in this quick overview section, what I want to do is I want to talk about what is RAG, why do we need it, and then I want to do a high level overview of just running through a simple example, just so everything makes sense whenever we start to dive into these code examples that I've set up over here for you guys. Okay, so let's just go ahead and just talk about what is RAG at a super high level and kind of why do we need it. Well, these large language models that we have set up like ChatGPT, Gemini, and Llama 3, all of these models have a constraint on how much knowledge they already have. And that can be a problem whenever we want to start answering questions or whenever we have questions about additional things, such as hey, what's happening today in the news? Well, these LLMs have a cutoff date of, a few months or even a year ago, so it has no idea what's happening right now. Also, when it comes to maybe just inside of your company, you have some specialized documents for y'all's processes, or you have some other information about a product you're building. Well, the LLMs obviously don't know anything about it, so it's up to us to use RAG to feed in additional new information to these LLMs. So under the hood, all we're trying to do is just give these LLMs additional information so they can answer our question. That's all that's going on at a high level. So as you can see, we can feed in things like PDFs. So whenever you hear people talking to PDFs or chatting with them, that's exactly what's happening. They're using RAG. So we can feed in websites, we can feed in source code and video transcripts, and the list goes on and on. But okay, that's enough at a high level. So what I want to quickly do next is let's dive over to a big example that I set up for you guys where we're going to walk through exactly how RAG works at a super high level. So when we hop over to the code and we go through all these different examples, you'll have a high level understanding of oh, that's why we're doing what we're doing. So let's go ahead and dive into that high level overview right now. All right, guys, so welcome to this quick overview of how RAG works. Now, I've put together this flowchart for you guys so that we can understand two critical components of working with RAG. And I'm going to walk through both of them at a high level and kind of go super quick because we're going to go through this a bunch more times as we actually dive into the code. But the main thing I want us to take away from this demo is for you to understand the core high-level concepts, such as terms like vector store, embeddings, LLMs, chunks, tokens. We're going to just quickly say all these words, and it'll mean a lot more when we dive into the code. And that's what we're going to be covering in part 1. And then part 2 of this quick demo, I want to walk through like, great, well, once we have actually saved all of the information from our PDF over to this special database called a vector store, well, how can we actually start asking questions and pulling out information so that we can get a AI generated response that's informed? Meaning, if we're, chatting with a document about how to like cook a specific food, well, we want to pull out the specific instructions for that food along with our question to generate an AI response. So that's what we're going to be talking about at a high level. And we're going to go part by part, and this will hopefully all make sense. And I do think one of the core parts to help this make sense of like why we're doing what we're doing is to actually start at the vector store and work our way back up so you understand why we're doing it. And this will make more sense. So hang on for 2 minutes and it'll make all sense. Okay, so at the end of the day, everything that we're trying to do comes to this part right here. It's the bridge and connection between our database, which stores all the information about our text source, plus this retriever. And this retriever is where we're going to like, hey man, please give me all the information about, let's just say we're working with Harry Potter and we ask like, hey, which professor also is a werewolf? Well, what we want to do in this example is we want to be able to look up things such as like professor and werewolf. Well, if we were manually doing this, what we would do is just like Command F in a PDF and just search for those words 1,000 times. But there's going to be a ton of entries, and what we're trying to do is really find a werewolf and a professor. That's the information we're looking for. Okay, so what we're trying to do, and this is a keyword here, we're trying to look for similarity inside of the original text source that we're looking for. That's all we're trying to do. We want to look for similar pieces of information inside this original PDF that talk about professors and werewolves. Okay, so that's all we're trying to do here. Now, well, how does this actually come into play when it comes to RAG? Well, what's going to happen under the hood is this PDF of Harry Potter is going to be broken up into 1,000 different chunks, because you can see this PDF has about 10 million tokens, and that's way too big for us to answer any questions or like analyze what's going on, because ChatGPT has a window of about 8,000 tokens, and 10 million is obviously way too big to pass into it. So what we need to do, because we're just trying to pull out the similar pieces of information and pass it over to ChatGPT so it can generate an AI response about it. So what we need to do is we need to split this up into a bunch of smaller chunks that are about 1,000 each. What's great about this is because, like I said, ChatGPT can take in 8,000 prompts, 8,000 tokens. So if we pass in one chunk up to 3 or 4 chunks, there's still plenty of room for us to also pass in a question about those chunks. Okay, hang on, we're getting there. All right, well, each one of these chunks is just plain text. So you can see like chunk 1 is just like, Harry, you're a wizard. And, and basically how this is working under the hood is we're just starting at the beginning of the book, taking out 1,000 words, putting it in a chunk. Getting the next few thousand words, putting in another chunk. Well, the problem is we said our original goal is we want to look up similar phrases. Well, how the heck does AI compare and search for similar phrases? Well, this is where the term embedding comes into play. And embedding is nothing more than the numerical representation of text. So that was a mouthful. What does that actually mean? Well, if we were to like, in this super simple example, if we were to embed the word dog, cat, and house, you can see that a dog has this embedding, a cat has this embedding, and a house has this embedding. And you'll notice they're nothing more than just a list of numbers, but they actually, under the hood, have some meaning and relationship to one another. So for example, a dog and a cat are super similar. The only thing that's different are these last 2 numbers. But even then, they're not that different because they got 4 legs, they're furry, they live in a house. But a house, on the other hand, it's got a roof, it's got walls, brick. They're completely different subjects. So if we were to ever like search about dogs or animals with 4 legs, well, these 2 things would come together. These are super similar, so we would get responses about dogs and cats. So the point I'm just trying to get across is embeddings allow us to easily search for similar items. And the way we're able to do this because like machines love numbers, and numbers are easy to compare and see how different and similar things are. Okay, So what we're going to do is we're going to convert these chunks of text over to embeddings so that we can easily compare them and contrast them. And once we have all these different chunks of text embedded, what we're going to do is start saving the embedding plus the original text to a vector store. And the reason why this is important is because, going back to our original problem, what we want to do is we want to be able to ask questions and retrieve related documents from this vector store. All right, so now let's walk through this flow down here now that we're in part 2, and you'll see exactly why everything that we just did above is super important. So going back to us with our Harry Potter fans, if we ask a question, which professor is also a werewolf? Well, that question will be embedded itself, because what we're trying to do is we're trying to look up similar documents to our question. And the way we're able to do that is because our embedding will now have a numerical representation of professor and werewolf. And then eventually, because now it's embedded, now whenever we go to it's going to be called a retriever. Whenever we use our retriever to look up similar embeddings in the vector store, it'll go like, oh, well, chapter 4, paragraph 1, 2, and 3 all talk about this professor that's a werewolf. Let me give you back those chunks of data or those blobs of text so that you can then ask questions about them. So that's all that's happening under the hood. We go, step 1, here's my question. Here's my embedding that has my question. Great. Let's return this chunk and this chunk because those were the most similar. And once we have those chunks returned, what we can do is pass them over to ChatGPT. And what's going to happen under the hood that you'll see is all that's doing is just adding those pieces of text at the very beginning of our prompt. And then at the very bottom, we'll have our question. And then we can now ask questions about those pieces of information. So what it will really be is like, which professor is a werewolf? And then these 3 chapters or these 3 paragraphs will have all the information we need to generate an AI informed response. Now that was a ton of information. Don't worry, we're going to go part by part when we look at the code. It's just at a high level. The main thing I want you to understand is we have huge text sources that have way too much information for any AI to consume. We need to break it up into smaller chunks. Those chunks need to be converted over to embeddings. The reason we need to do that is because we need to see how similar each different chunk is to one another, so that later, whenever we go to ask questions about those different pieces of text and embeddings, we can go, oh, yep, these 2 are super similar. Here's the information you requested back so that you can ask a question. So that was a mouthful. Let's actually go ahead and start diving over to the code now so we can see all this in action. And I promise you, after you see this a few times, it'll all make sense and you'll be able to start building your own RAG use cases. So let's go ahead and hop back over to the code. All right, guys, so welcome to the first code example inside of the RAG module, and I'm super excited for you guys to see how everything ties together that we just walked through in the high-level drawing. So this is exactly where you're going to connect the dots. And just to paint a roadmap of what we're about to do is I have broken up the first code example into 2 parts. As you can see, there's a 1A and a 1B. 1A directly ties to the initial breakdown of what we were setting up top in our initial drawing, where we were first converting some text source over to our vector store. So that's going to be in 1A. And then 1B is going to be all about actually asking questions and retrieving documents from that vector store. So everything we talked about when it comes to like embedding, chunking, saving stuff to the vector store, that's all going to happen in 1A. And then building our retrievers, once again embedding, you're going to see that all in 1B. Okay, so we're going to go ahead now and start walking through this code part by part. And some of this code is a little bit more advanced just because there's a lot more moving parts. But don't worry, I'm going to cover everything. And once again, if you have questions, you can always head over to the free Skool community I created for you guys. Just take a screenshot or a timestamp of the video and say, here's where I'm stuck. I don't understand this. And myself or someone else in the community will be sure to help get you unstuck so you can keep going and building out your awesome projects. All right, so let's go through this part by part and also walk through some of the folder structure just so it all makes sense. Okay, so the first thing that we're going to be doing is inside of 1A is we need to set up some file paths so that we can connect to different parts of our project. So the main things that we need to connect to is our initial text source. So this is the document we're going to be asking questions about. In this case, we're going to be asking questions about the Odyssey. And you can see how we access that book is by looking inside of our current directory. Go to the books folder and then look for the Odyssey text. So if right now my current directory is inside of the RAG folder, if I open up books, you can see that I actually have the Odyssey text file right in here. So that's how we're going to access that. And the next thing is you can see I have this, what I'm calling a persistent directory. So that's actually just where I'm going to be storing our Chroma database. And same thing, this one, we just look at the current database, open up the DB folder. Whenever you start to save files, this will actually auto get created, so you might not see DB out the gate. And then next, we're going to save everything to the Chroma DB folder. So that's what you can see. Now this is, since I've already ran this code before, I already have this, but I'm gonna delete it, so I'm on the same page as you guys. Okay, cool. So let's keep chugging along in our code, and so you can understand what's going on. So if you remember, the first part of what we're trying to do in this high level code is go from a text source over to our vector store. So if we've already went ahead and chunked our document, converted everything to embeddings, and saved it to our vector store, there's no reason to rerun 1A. So this is why I have this code right here. It's just gonna say, hey, does a persistent directory already exist? In this case, the Chroma DB already exists. If it does, just completely skip all of this, because there's no reason for us to go off and, there's no reason for us to go through and pay, because embeddings do cost money to convert from text to embeddings. So we're just going to completely skip it. But if we do not have that persistent directory, what we're going to do is go off and actually set everything up. So the first thing that we're going to do is we're going to start at the top and actually load in the file path. And what I'm going to do to help this make sense is we're just going to quickly hop back and forth from part to part so it all makes sense. So first thing, we are going to load that file path, which is connected to our Odysseus text, and we're going to use a text loader. A text loader is just a great way to actually point yep, here's the file path to my document that I want to load. Later on, we'll talk about things like web loaders, to where you can actually pull information from the websites, but I just want to expose you to the realm of the possible. But for right now, we're just going to load a text document. Once we have that file loaded, what we're going to do is we want to actually start splitting up this document into small chunks, exactly like we talked about here. So far we've loaded it, and now what we're going to do is start chunking it. And there's a bunch of different chunking strategies that we will talk about later on in the text splitting deep dive. But for right now, just know we're going to try and chunk basically each section of the book every 1,000 characters. And just to go a little, help explain a little bit more, just so we're all on the same page, you can also set this thing called chunk overlap. And all that does is, let's just say this is a chunk of text, and let's just say in the middle of a paragraph was 1,000 characters. What it'll do is it'll cut off. So you kind of get cut off in the middle of a sentence. And then when you load the next chunk, it's kind of like, well, I have a query about the end of the first chunk, but it's about the second chunk too. So I don't know, it's just difficult for us to understand semantically what's happening in a chunk. So what you'll notice a lot of times people do is they'll set some overlap. So what that'll mean is just you'll always grab a little bit of the next section too. That way there's just always overlap, and a lot of times you'll get better performance results. So a lot of times, just to give you numbers, a lot of people will do things such as 200 or 400 or common values. So yeah, but for right now, for our example, we're just going to keep everything lean and mean and set the chunk size to 1,000 tokens. Fantastic. So once we have set up our text splitter, what we're going to do is actually split up our original document into a ton of those chunks that you see right here, where each one's going to be 1,000 tokens. Now, once we have all of our chunks, it's also docs, whatever you want to call them, what we can do next is we need to start moving over to embedding them. Now, in this case, we're just going to use the OpenAI embeddings, and we'll actually go through later on in an embedding deep dive to show you other options that you have. But for right now, just know that we're going to use OpenAI to convert our text chunks over to embeddings. And we're going to be using the text embedding 3 small model. And there's actually a few different models that you can use. There's one that's the 3 small, which is the cheapest one, and that's one I primarily use. And there's also a 3 large. Just know, as we talked about earlier, there's this things called numerical representations, which were just long arrays of a dog is equal to an array of 1, 2, 3. Well, the large model just has a lot more values, so we can get a lot more precise with our embeddings. So just know 3 small is probably completely fine for the projects that you're working on. Okay, let's keep chugging along. So once we have set up our embeddings, what we're going to do is we're going to use our Chroma vector store to actually save all of our documents with our embeddings, and we're going to say you are going to save the results over here into this persistent directory. So what I'm going to do is I'm going to run this just so you guys can see what it looks like under the hood. So we're going to run Python. This is the 4th module, and this is 1A, and we're going to run rag basics. I'm going to zoom out so we can actually see it. So you can see we're creating our embeddings. we're finished creating our embeddings, and then now we're going to create our vector store. And if you scroll up actually a little bit, you can see we saved a little bit of our first chunk, because in our code we said, how many chunks did we create? In this case, 826, where each chunk is 1,000 tokens. And you can see the first sample chunk. And this first sample chunk is actually the very first part of the book. So if you go open the book, you can see at like line 1, this is the exact same. So yeah, we've actually just, this is working. Hope you guys are hyped to see it's all coming together. All right, so let's go back down to the bottom so you can see our vector store is created, and we can confirm that by going over to our database folder and checking for our ChromaDB. And you can see at the beginning, DB ChromaDB, yep, it made it. And just to show you guys, if I actually try running it again, the way we've set up the code is it'll give us an alert saying, yep, this vector store is already created. No need to redo it. Cool. So now that we have that set up, let's go ahead and move on to part B, where we can actually start asking questions and pulling information from the vector store. So let's walk over here to 1B and start going through this once again, part by part. So per usual, what we need to do is we need to point to our vector store so that we can actually start, referencing it. So in this case, copying the same thing, look inside our current directory, then actually access the database folder and look for ChromaDB. Once we have that set up, we need to specify which embedding we're going to be using. And it's important to use the same one, just so that, you wouldn't want to change languages when you're asking questions. So we just need to be very specific and use the same thing consistent, or else you're just going to get some weird results. Fantastic. Next, what we're going to do is we're going to use ChromaDB. Once again, we're just going to spin it up saying, yep, here is the persistent directory where you've already saved all of your embeddings in those text chunks. And here's the embedding function so that whenever you get asked queries, you know how to go off and do a similarity check and see which relevant documents are the most similar. All right, so in this case, all we're going to do is, for this question, we're just going to ask the Odyssey. So the main character is Odysseus. We just want to know who is his wife. So this is the query that we're going to be asking to our vector store. And I do think it is important for you guys, if you haven't seen what vector stores look like, I think they did a great job. This is the ChromaDB website, and I think they did a great job of helping you guys visualize what's going on. So under the hood, you can see we're going to ask a query. So who's Odysseus' wife? We're going to convert that query over to an embedding. Once we have that embedding, what we're going to do is access ChromaDB, and it will pull out the documents and their connected embeddings, because that's how we can do the similarity score. And we can see oh, this one's the most similar, and here's the related document. Let me pass that back. And once you get passed back, it eventually gets passed back to your whatever LLM you're working with and generate that AI response. So I just thought this was a neat little graphic I wanted to show you guys. Let's go back to ours though, so we can keep cranking this out. So what we need to do next is work on that retriever. And the retriever is what's going to take in our query and eventually return back those related documents. But when we're setting up our retriever, we have a few different options for what we can do. And per usual, what we're going to do is I have a deep dive later on so you can see all the possibilities when it comes to working with retrievers. But for right now, just know we have a few different search types that give us different results. And for this example, we're going to be doing a similarity score threshold. All that does is pretty much exactly what it says. It's going to do a similarity check to find the most related documents, and it's only going to return documents that, up to us, how similar. So this number, you can see we have something called a score threshold. Well, the higher this number is, the higher the text document has to be to our query. And we'll play around with this just so you can see it in action. And the other argument that you'll see is this random letter K with a number. So what the heck is that? Well, what it's going to do is it's going to return the K closest documents. So if there was 100 documents that were, above this threshold, what this will do is it will return the top 3 closest results. So that's how you have to kind of set up your retriever if you want to do this. And feel free to bump this number up or down. Just remember, depending on which LLM you're working with, you're kind of capped at, right around usually 8,000 tokens. So in this example, we're going to be pulling out 3,000 tokens whenever we're all said and done and passing it to our LLM. Okay, so now that we have set up our retriever, set up the parameters, what we can do is we're going to call that invoke function. Remember, we talked about that a lot in the chat model section. Invoke is the magic word inside of LangChain for actually taking action on the models that you set up. So in this case, on our retriever, we're going to pass in the query, invoke it, and it's going to give us back the relevant documents. So I'm going to go ahead and run this, and then we're going to play around with some of these parameters just so you can see what's happening under the hood. And I do want to point out, all we're doing in this example is just showing the relevant documents. Later on, we'll actually pass these documents over to a chat model so we can start interacting with them. But for right now, I just want to show you guys that yes, our vector store is returning related documents, and we'll just look through them. Okay, so let's come down here, clear this up. We're going to run inside of our fourth module. We're going to run 1B to actually start grabbing those documents, and let's run it. Okay, so what I would expect is to eventually get back 3 different documents that relate to Odysseus's wife. So you can see we have document 1, document 2, document 3. That's cool. It also includes a source. We'll talk more about that later. But the main thing right now that you can see is his wife is Penelope. So you can actually like kind of see like we're talking about in this document. We'll actually just do a quick search. So you can look up like the term wife. It gets mentioned in a few of these documents. So yeah, you are indeed blessed in the possession of a wife endowed with such rare, excellent of understanding, and so faithful as Penelope. So that's like, you can see this document perfectly describes, like this is his wife. So, and the other documents too kind of talk about, some of the other, they refer to wife, so they're not as similar, but you can see this was the closest one. That's why it's document number 1. All right, now that you've seen that work, what I want to do is show you how we can play around with some of these parameters to get different results. So I can actually bump this up to k equals 10, and I'll bump this down. So we're lowering the threshold and saying we want more results. So what we're going to do is I would expect to get back a bunch more documents this time that are related to a wife. So you can see, yeah, we got back 10 more documents this time. Let's see how many times his wife's mentioned, Penelope. Yeah, so these are getting less relevant. 7 out of the 10 documents refer to her. Okay, so what I want to do next is I want to show you guys what happens if you get a little too stringent. So let's just say we only want to have documents that are like super, super close to our initial question. So if we were to run this updated code where we've updated the threshold to 0.09, meaning like very, very similar, what we'll do is we'll probably run into the problem of like, hey, you were too strict with your search results. I couldn't find anything. So we're going to give it a second. And whenever it gets back to us, it'll probably tell us, hey man, cannot find that. Oops, it looks like there's a quick bug. Let me just close this out, clear it out. Let me try this one more time. And now it should hopefully give us back an answer. Yeah, so you can see this time, for whatever reason, it just hit a bug. But yeah, there are no relevant documents that were retrieved using the relevant score 0.09. So we know we got too strict. So that's just, as you're building your own RAG applications, if you're not getting back results, you might just be a little too strict with your similarity score. Okay, cool. Well, that's it for module number 1. Now what we're going to do from here is just to paint a roadmap for you guys. We're going to head into part 2 where we're going to start adding metadata to our documents so we can actually kind of see like, oh, this is where this source came from. So we're going to go ahead and learn how to add metadata and view it in our requests. Let's go ahead and start working on that now. Hey guys, so welcome to the second example inside of the RAG tutorial. And what we're going to work on in this one is start setting up metadata. Now, why is metadata important in context of RAG? Well, it all has to come back to the fact that LLMs hallucinate. And what I mean by that is hallucination is a really nice way of saying they just get stuff wrong. But what's cool is whenever we start adding in metadata to our RAG queries, what we're basically doing is allowing our LLMs to respond with like, here is the source of information for where I'm generating this information I'm passing back to you. So if we were asking a question about a meeting that happened in the past at our company, it would tell us like, oh, John said this and Bob responded with this. And it would say, and here's the source where I got this information from. So you could always just click the source, go check it out on your own and be like, oh yeah, that is exactly what happened, and dive into more of the details that went on in that meeting. So that's metadata at a high level. Now let's actually dive into the code example so you can actually see how we set this up in practice. And you're going to notice this is super similar to the RAG basics tutorial. We're just adding in a little bit more complexity so you can understand all the capabilities of working with RAG. Okay, so per usual, what we're going to do is set up our current directories. But this time, what you're going to notice is instead of loading a specific book, we're loading a bunch of books. And that's because what we're trying to do in the end of this tutorial is ask about a certain character in a certain book, and we would expect the documents to, we would expect our retriever eventually to only respond with documents related to that character. So you'll see exactly what I'm talking about. We're going to ask about in Romeo and Juliet, so we would expect to only get back information about Romeo and Juliet and the metadata related to it. But you'll see that set up in just a second. Okay, so what we're going to do this time is we're going to start using a different database. So this time we're going to be using ChromaDB with metadata. I've already set mine up, and you'll set yours up in just a second. But the main thing, this code is identical to the other one. We're just going to check to see, hey, does this persistent directory not exist? If not, let's just go through that main process we talked about last time, which is going to be, setting up our vector store. If we already have the database, completely skip it. So let's walk through what's happening under the hood when we are setting up this vector store, because there are a few differences in this one. The main one is, to start off, is we are going and searching through each one of the files in our books directory, and we're going to grab all the files that end in a .txt. So we're going to be grabbing all of these different books right here. And what we're going to do with these book files is we're going to iterate through each of them and start copying the same process we did last time, except for one tweak where we're going to add metadata. Here's what I mean. First, we're going to actually set up a new file path by joining in, the name of the book file with our local books directory. Then we're going to load that book just like we did in the last example. But what we're going to do now is, once we have that document loaded, we're going to add some metadata to it. In this case, we're going to set up this source for this document. So whenever we're loading, for example, the Frankenstein book, we're going to say the source of this book is Frankenstein. Or whenever we're looking at the Iliad, what we're going to do is retrieve a document. It's going to say the source of the retrieved information comes from the Iliad. And you could definitely get a lot fancier with this. You could break up your documents and set it up to be per chapter, or per, if you had a long meeting, you could set it up to intro, speaker 1, speaker 2. You could do it however you wanted to, just so whenever you're setting up your metadata, you could have like chapter and so forth and so forth. But in this example, we're just going to stick to a book source. Cool. Once we have set up our metadata, we're just going to add it to our documents array or list. And then from there, we're going to copy the same process. First, we're going to iterate through each one of those documents that we have, and we're going to use our character splitter to chunk everything up into 1000 tokens. Once we have our docs, we're going to do the exact same thing, where we're going to pass in our docs plus our embeddings over to our vector store down here, so that we can go ahead and save everything. Okay, so I hope this is making sense, because now we're going to hop to 2B so we can actually start asking questions to our vector store and pull out documents. So what we're going to do in this example is, once again, set up our file directories and make sure we point to that new vector store that we just set up, the one that's going to be having metadata. So this one right here. And what we're going to do is we're going to use our new embeddings plus our vector store so that we can instantiate our new Chroma instance, so we can start passing questions to it. Now, this vector store retriever is the exact same as last time. All we're going to do is just use similarity score. I want the top 3 results, and here's my threshold. I set it super low for this one just because, for whatever reason, it was being a little weird. However, let's go ahead and run this code so you can see what it's doing under the hood. So we will do Python. We are in the RAG module. This is the second example, 2B. So we're going to go ahead and run it. And what I would expect to get back is information on how did Juliet die plus the metadata. Okay, so you can actually kind of see it right here. Like in document number 2, Juliet's talking. She obviously thinks Romeo killed himself. And out of true love down here, she stabs herself. So like you can, it actually went ahead and just gave us the exact piece of information we were looking for, which is crazy that it did that so efficiently. And the part that's extra cool is you can see this is the source where this information came from. So you could go back and double check the AI to make sure it didn't just come up and hallucinate with some weird facts. But yeah, that's how adding metadata to your RAG queries works at a basic level. I hope you guys appreciated that. And what we're going to do next is actually start doing some deep dives into each of the elements that we have been using to basically do our RAG queries. So we're going to head over next and do a deep dive into text splitting. Then we'll, keep going down the chain from there so you can see all aspects and how we can add in some variety to our RAG queries. So let's go ahead and move over to part number 3. So welcome to example number 3 inside of the RAG module. This example is all about going deep into different options when it comes to using the text splitter. So what I mean by that is there are a bunch of different ways you can actually go about splitting up your large documents, and you're gonna, in this example, explore all of them. So how to split it up based on characters, sentences, paragraphs, and more. We're gonna be doing all of that in this example. And we're actually going to be spinning up a bunch of different vector stores so that you can see how all of the different text splitting methods compare and contrast when we actually make a query. So you'll see exactly what I'm talking about here in just a second. And per usual, we're just going to start at the top of the code, work our way down so that you understand everything that's going on. All right, so let's go ahead and dive into the code. So the first thing that we're going to be doing is setting up basically our normal file directories. So we're going to just say yep, this is the book we want to analyze, and here is the path to our databases. And you'll notice that we don't have a specific database called out yet. And that's because we're going to be dynamically spinning up about 4 or 5 vector stores down below. Okay, so what we're going to do, just make sure everything exists, and we're going to do the normal, kind of set up our normal loaders. This time we're just going to load our book, Romeo and Juliet, grab the document, and stand up and specify our vector store, or sorry, our embeddings. Now here's where things get interesting. What we're going to do is, you can see I have, I think, 5 different examples to show you guys. And each one of these examples kind of specifies which text splitter we're going to be doing and when it's useful to use this text splitter, just so you guys always have a reference to come back to of like, oh yeah, I think it was text splitter number 3 that was good for this scenario. And you can always just come back and actually explore. But here's what's happening at a high level, and then we'll dive into this vector store function. That's a little bit kind of, it's different. So what you'll notice is we're going to specify a specific type of text splitter along with the parameters we want to use. And after that, we're then going to actually go ahead and split up the document. And once we have all those split up chunks, what we're going to do is then call this create vector store with all of our chunks. And then we're going to give this database a name. And once we do that and pass over that information, we're going to call this create vector store. And what you can see in here is we're going to finally specify our persistent directory here, and then actually go ahead and save everything to our new Chroma database. So that's exactly what's happening under the hood. Okay, so let's walk through each one of these, and I'll tell you when you should use each method. And then at the very end, we're actually going to go off and query the vector store. Okay, so to start off, the first type of splitting we're going to do is just the normal character-based splitting. In the past, what we've been doing, I'm just going to show you what we've been doing for 2A in the past. So you can see what we've normally been doing is character-based splitting. So this is nothing new. This time we're just adding some overlap, and you can see this is a great method to use when the type of your content doesn't really, like, there's no syntactical kind of meaning. For example, like if you're reading a book, we talked about maybe keeping paragraphs together because we kind of want to like keep chunks of information together. So this is just great when we just need to chunk up and split a bunch of random information. The next example I want to show you guys is sentence-based text splitting. So this one is when we actually want to split things based on, a sentence. So this way, maybe paragraphs are too long. So we're just going to split everything based up on sentences. So we're going to look for, periods, exclamation marks, question marks. So, and that's how we're going to split things up. And once again, we're going to be splitting things into chunk sizes of 1,000. We're going to call this our ChromaDB sentence. Then keep chugging along. The next one is going to be our token text splitter. And so this actually splits based on a token. So in this one, what's going to happen is we'll actually maybe split in the middle of a word. So if, let's say, a word was super long, and maybe the first part of that sentence was right over the chunk limit, well, half of the word's going to get cut out. So I would not recommend this for a lot of like documents based, but I just want to show you guys that this does exist. All right, the next one that I just want to show you guys is going to be the recursive character splitter. This is the one that I would actually, most people use. I've seen people use this the most, and I would definitely recommend using number 4 the most, because like it tries to naturally split around sentences and paragraphs within the character limit. So it does a really good job of like making sure the information that gets pulled out just kind of, it makes sense. It would make sense for this cluster of information to be stored together. Okay, cool. And the final one I just want to show you guys is going to be custom text splitting. And all we're doing with, just to show you guys, we can make our own splitters. And these splitters you can specify like, oh, I want to split chunks based on at the end of a paragraph. So this is what this, double backspace, it's a double escape, or 2 new lines. So in our case, we're assuming that's a new paragraph. Okay, cool. And we're going to save that custom text splitter to our ChromaDB custom. Fantastic. So what we're going to do next, I'm just going to show you, is for each one of our databases that we just sped up, vector stores, we're going to go off and query those vector stores with this question: how did Juliet die? And the way we're going to do that is we're going to pass in the name of the vector store along with our query to this function right here. And all it's going to do is look up our persistent directory. That's going to be our vector store. And we're just going to do the normal thing that we've done so far, to where we have our vector store, we set up our retriever, set up, our search parameters for similarity score, and then we're just going to grab the relevant documents and spit them out. So that's exactly what we're going to do. So let's go ahead and start running this query to embed everything first off using the different text splitters and start asking questions. So let's go ahead and run this. And this is our third example. So let's go ahead and do, this is in the RAG module, and this is example number 3. So let's go ahead and run this super fast. And this one will take longer because we're doing 5, 6 different types of embeddings, but you can see that it's working. We're creating everything. So far we're doing it for characters. Next we're going to do it based on sentences, tokens, and then from there our recursive, and then finally we're going to do our custom text splitter. And once this is all done, we're going to then finally ask, hey, so how did she die? And you can see, let's just go result by result real fast just so you can kind of compare each one. So the first one for character, this is what we've been using so far, and this does look super similar to what we've been doing. It's just a lot of text. From there, what you can see when it comes over to the sentence one, this one actually looks a lot more structured. And then finally, let's just keep going along. When it comes to our token, what I would expect to see at the very end of this one is like it get cut off at a random word. So in this case, it got cut off right at my, but if this had been a longer word, it would have got cut off and we wouldn't have been able to we could have potentially lost some information. When it comes to our recursive text splitter, you can see that this has done a really good job, cutting at the very end of a sentence. So that did a really good job, or verse. I can't remember what happens inside of how Shakespeare wrote. And then finally, when it comes to doing our custom DB, it kind of just, the way it chunked it just didn't do a good job. And that's because the way we sped up to split based on 2 new returns, it just didn't do a good job of grabbing information. But the main thing I just want you to learn is there's a ton of different ways that you can actually go about using different text splitters to grab information. My recommendation for you is to always use the recursive text splitter whenever you're starting out, and then you can get a little bit fancy using the token and text splitter and some of the sentence ones. But just main thing, always use the recursive. But enough of that, let's go ahead and dive into the next module where we're going to start talking about the different types of embeddings that you guys can use inside of your RAG setup. So let's go ahead and dive into example number 4 right now. So welcome to example number 4 inside the RAG module. And in this example, we're going to do a deep dive into embeddings just so you can see what's possible. Okay, and just to give a little bit of background, so far we have strictly used OpenAI's embeddings. And in this example, I'm going to show you how you can start to use custom embeddings, why you'd want to do that, and show you some other models inside of the OpenAI embeddings that you might want to use. Okay, so let's quickly run through the code so you can see what's going on, and then at the end we'll run it so you can actually compare and contrast 2 different results using 2 different embeddings so you can see which one works better and which one doesn't. Okay, so what we're going to do is our per usual, we're going to load in a book that we want to ask questions about. And what we're going to do in this one, per usual, you'll see we have a database directory because we're going to end up creating 2 different vector stores in this example. And after that, what we're going to do is per usual, go ahead and load our document, and we're going to split it up. In this case, we're just going to use the character splitter. And once we have that set up, what we're going to do is we're going to end up using this function called create vector store. More on that in a second. The important part is I have 2 different embeddings down here. So let's walk through each one super fast. So the first one is, once again, like I said, we're just going to be using the OpenAI embedding. And so far we've been using let me go ahead and just show you the exact one we've been using. We've been using, it's called text embedding 3 small. This is the embedding that we've been using the entire tutorial. And now we're branching out and we're going to be using the ADA embedding. Okay, so let's actually go ahead and look how these compare price-wise and actually look at what the different options you have. So over here on the OpenAI website, you can actually look up embedding, and you can see there's a few different examples. So this one is going to be the ADA example version 2. This one is one of the more pricey ones, and you can actually go under the hood and look at the different options they have. So ADA, so you can see if you scroll deeper down, they have different qualities. So the ADA example it performs a little, it doesn't perform as well as some of the other options, but you're able to add more data compared to the large model. So it's all a pro con, but personally, I just go with the small model for most of the stuff I work on just because it's the cheapest and you get really good results, but there are other options and I just want you to be aware of that. Okay, all right, let's hop back to it. So what we're going to do in this case is we're going to create a new OpenAI embedding using this new model, and that's option 1. And like I said, these OpenAI embeddings, they're best just for general purpose with really good accuracy. And then, but remember, you have to pay because this is all happening on OpenAI servers. Now, option 2, what this embedding is going to be, is we're actually going to download an embedding model from Hugging Face. Hugging Face is just I'll just go ahead and show you guys what it is so you can see it in action. So let me pull up these models for y'all real fast. So as you can see, whenever we head over to Hugging Face, which is just a great place to go ahead and download models that other people have created locally on your machine so you can run them completely for free. So you can see there's a bunch of different models here. and we can actually search for embeddings. We actually are already searching for embeddings, and you can see there's just a ton of them. Yeah, dozens. But in our example, what we're going to do is use one of the more common ones, which is just going to be a sentence transformer. And all it's going to do is its main thing is it's going to, like I said, it's basically just going to run locally and perform embeddings. Personally, I don't really use these that much. I just want to show you what's possible. The main pro and the reason why you would want to use one of these models from Hugging Face is because you can run it locally for free, which is one of the biggest benefits. It's usually not as performative, so you're kind of trading performance for cost. So it really just depends where you fall on that spectrum. Okay, so what we're going to do next is, now that we have gone off and specified the two different embedding models that we want to use and the different names we want to call these different models for our vector stores, we're going to go ahead and create those databases. Now, you've seen this before. What we're going to do is just pass in the embedding, and this is going to just pass in right here. So we're going to set up the vector store name, and then we're going to say which embedding to use. And that's how we're going to go off and create our two vector stores, one for OpenAI and one for Hugging Face. Now, it is important to mention whenever you do use this embedding, because it is running locally on your computer, you're going to download a pretty big file. I think it's half a gigabyte, but that's how big the file is to perform your embeddings locally. So just beware, if you're going to download this code and run it, it does take up a good bit of space, and might be even more. Okay, so what we're going to do next is we're going to do our normal comparison, where we're just going to ask a question to our vector stores, and we're just going to compare the results of OpenAI to our Hugging Face example. So let's go ahead and open this up, and we're going to run our fourth example. So because we're in the RAG module, fourth example, going to go off and run it. Now, what you'll notice is I've already gone ahead and actually created these models in the past. So it's not going to generate a new Hugging Face transformer because I've already done it in the past. But you will see that we are going to be able to query these documents. So in our OpenAI example output, let's see what words we get back. So we didn't actually get a good example in either one of these. So what we can do is update our vector store, and we can actually update our K to get back more results. Clear it, run it again. And this time we can actually hopefully search to see if we got back any information about Odysseus' wife, who in this case is Penelope. And it's so funny because sometimes you'll get back an example that does include the right information. So you can see now it just changes per run. So you can see now in our Hugging Face example, we got some information about Penelope. We got one of the documents contained information about her. And then if we go back up, you can see that our OpenAI example came back with a few more examples talking about Penelope. So overall, they both got towards the right answer. It's just OpenAI returned back a lot more relevant information. So kind of what we expected. It's more performative at the cost of spending a little bit more money on it. Okay, cool. Enough with doing our embedding deep dive. What we're going to do next is we're going to move over to working with retrievers and learning about different search types and different arguments we can pass in to our retrievers. And this is really going to help up our game when we're working with different RAG applications. All right, let's go ahead and head over to example number 5. So welcome to this fifth example in the RAG module. In this example, we're going to be doing a deep dive into retrievers and understanding all the different ways we can actually update how we search for different documents inside of our vector stores. So that's the main goal of this quick deep dive. Okay, so what we're going to do as a high level, just to also understand, we're going to, by the end of this example, showcase how by fine-tuning different search parameters in our retrievers, how we're going to get different results. So you're going to learn more about different types of search queries and different ways to basically, pass in custom parameters for those different types of searches. And we're going to be able to, at the end of this, compare and contrast the different results. Okay, cool. So let's quickly run through this one. So the main thing, we're going to do our normal part of setting up accessing our vector store. In this case, we're going to reuse our old vector store, which included all of our metadata. So this is the one that had all of our books with the different sources. Outside of that, we're going to use our usual embedding model. We're going to spin up our Chroma DB instance. And then from here, what we're going to do, I'm going to close that out, and we're going to come back to this query vector store. But what you can see is we're trying out 3 or 4 different examples of searching inside of our vector store. So what you'll notice is, let me just show you like a compare and contrast. So the first thing is we pass in the name of the vector store that we want to search the query. So this is like, hey, what question do you have? What type of embeddings are we going to use? And then here comes the important part. We're going to pass in what type of search, basically what type of search model we want to use, and then any parameters. So let's actually hop into this query vector store so you can see all this in action under the hood. So like I said, you can see the search type and the search type parameters right here. So we're dynamically spinning up and creating our retriever, because that's the main area that we're focusing on in this tutorial. We want to compare and contrast all the different options. And not only do we want to like access these retrievers, we want to go off eventually and fetch information with these different types of retrievers so that we can compare and contrast the relevant documents, just so we can see like, oh yeah, this search type performs better than this search type. Okay, so let's hop back down to our 3 examples below so that you can actually see how they work. So far what we've been using is, and the rest of our code has been, let's scroll down so I can show you. We've been using similarity score with threshold basically. So this is how we say, yep, I want to get the top 3 results, and I only want to get back information that's over this score threshold. That way we only get back relevant data. However, sometimes you don't want to actually do that threshold scoring if you know for a fact, like, yes, every question I'm going to be asking is relevant to that database. You really don't need the threshold. So this is a very quick way to say, yep, here is my data store. I want to just grab all the similar results. Don't care how relevant they are, but I do want to grab the top 3 results. That's exactly what's going to happen with this similarity score. And there's no way of really filtering out the like, oh yeah, this one's not that relevant. Okay, the next one that we want to do is working with the max marginal relevance search query. So what does this one do? Why is it important? Well, what it does is it tries to not only get the most relevant information, but it tries to kind of spread out. Meaning if, for example, how we're going to ask about questions about Juliet's death. Well, what this type of search score would do, instead of, sorry, I'm going to compare and contrast. With this similarity score, let's just say all the top 3 documents about her death were all right next to each other. So it's just going to grab all of that information and maybe leave out some additional context. And what's cool about this max marginal result is not only is it looking for super relevant information, but it's kind of also looking for adjacent information around her death. So it's not just gonna be like, yeah, she died because of blank. It's going to maybe skip around to like a few paragraphs later that's also talking about her death, but it might not be the most relevant information to help generate a more well-rounded response. So very cool search method. And you can actually see, let's scroll down here so you can kind of see. So yeah, so K is how many different responses we want to get. Fetch K, specify the number of documents to initially fetch. So this is, you know, how we can actually kind of specify, like, we're going to grab a ton of documents, and then inside of that, we're going to return the top 3, and we're going to like space out those results. So you're going to get a well diversified set of results. So this is what you can see kind of right here. So feel free to play with this lambda multiplier. Like I said, the main thing it does is control the diversity. So if you want a ton of spread out information to get like as much wide range of context around the topic as possible, you're going to want to bump that number to 0 to get the maximum diversity. And if you want super similar information, keep it to 1. Okay, cool. So enough of that. I'm excited to show you guys this one actually running so you can see how it performs. And the final one, this is the one that we've been using the entire time, which is just our similarity score with a threshold. Okay, so let's go ahead and actually run this so you can see how it performs. And we're going to actually this time, because there's going to be so much information, I'm over here in my terminal, and we'll look at the results over here. So what we're going to do is run Python. This is in the RAG section, and we are on the 5th example. So we're going to go ahead and run this code, and it's going to go off and actually, oh, my bad. I need to actually load in my environment variables. I didn't do that real fast. We'll just quickly fix that on the fly. So we'll do load .env, and then once we have that, we'll come over here and import it. Fantastic. That was my bad. Save it. Now when we run it again, it'll work, and it'll actually go ahead and show all the different results for the different vector stores. Okay, so let's run through this part by part just so you can kind of see how it works. So the first example that we're going to look at, we have to come all the way up just because there are a ton of different examples. So the first one is just the regular similarity score. So you can see it's just going to return 3 different documents that are the most similar to our initial request, which was how did Juliet die? So we're going to get back a ton of information, and then hopefully one of these will actually include the way that she died. Yeah, so she stabs her health. So yeah, you can see document 2 include the exact pieces of information that we needed. So the next one that we were wanting to do was the max marginal relevant score. And this is the one that allows us to get not only the piece of information we want, but some of more of the contextual information around her death. So let's actually see if this result includes anything around her dagger. So this one does talk about, you know, laying her dagger down. And it also, yeah, this one didn't perform it as well as the other one, So this would be a good way for us to go off and actually potentially like, oh, well, maybe let's just get some less diverse information so we really hone in. So like I said, everything's a game and you have to optimize and tune those parameters to get the results that you're looking for. And the third one, which is our usual one, which is, hey, let's go off and actually get everything that's within a similarity score. This one is going to return, per usual, the one where she snatches a dagger and stabs herself. So like I said, there's a few different ways you can work with these different retrieval methods to experiment with grabbing information from your vector store. So I just wanted you guys to be aware of a few of the most common approaches. But enough of that. What we're going to do next is hop onto the next example where we're actually going to not only be retrieving information now, but we're going to actually ask a one-off question of like, hey, what happened? And we're going to get an AI generated response. Let's go ahead and dive into this example next. So welcome to example number 6 inside of the RAG module. I'm super excited for this example because you're finally going to learn how to tie all the information that we've been storing in our vector store. We're going to be grabbing that information and passing it over to an LLM so we can actually finally generate an AI generated response. So I'm pumped for you guys to see it. So now that you know what we're going to be doing, let's actually dive into the code so you can see how you can start chatting with your data. Okay. So per usual, what we're going to do is we are going to go off and grab our vector store location. Per usual, we're going to be chatting with our vector store that has all the different options from all the different books. What we're going to be doing is use our usual text embedding. From there, we're going to spin up an instant of our vector store. From there, we're going to be passing in a new question, and this one's just going to be, hey, how can I learn more about LangChain? And now that we have our query, we're going to set up a new retriever. And this one, we're just going to use the similarity search method, which is going to, like I said, just how we just learned about, it's just going to grab the most relevant document and it's going to return only one result. And from there, what we're going to do is use the retriever and go ahead and search our vector store for that query and return relevant documents. So it's important to realize that this is a list of documents. Now, in our example, we're actually going to print it so you can see the underlying document. But here's where the magic happens. What we're doing under the hood is we are generating our query, and we're not only going to just use our query, we're going to pass in the content from our vector store that we just pulled out, combine them, and we're going to use our chat models to generate a response. So this is going to be awesome. And let me just walk you through the prompt so you can understand what's happening at a high level. So the first thing is we are creating our prompt and we're going to say, here's some documents that might help you answer this question. Here's the question. Now here's the relevant documents. We could have probably used a prompt template to do this, and you'll see we're going to do some of that later on, but we could have even done it up here. And then what you're going to see is we're going to join, basically we're just going to do some string manipulation here to where we're going to grab all the content from our relevant document and really just spit it out in a nice text format. And if you remember, each one of these documents, because we set this up earlier when we were doing our embeddings, each one of these is going to be 1,000 tokens long. So we're going to have plenty of space to pass in this information into our query because, hey, we're only getting one result, so 1K tokens, and we have up to 8, so 8,000 tokens. So what we're going to do is once we have this combined input, we are going to spin up our new chat model, and we're going to use the latest version of OpenAI, so ChatGPT 4.0, and we are going to go ahead and generate our messages. And what we're going to do is pass in our messages with our combined input containing our query and all the information from our vector store into our model, and we're going to invoke it. And what this is going to do is generate a result for us, which is going to contain the AI response. And for this example, let's just only generate the content only so you can just see the actual response that it's going to say well, if you want to learn more about LangChain, here is my recommendation. So what we're going to do is go ahead and run. This is module number 4 for RAG. This is example number 6 for a one-off question. So let's go ahead and run it. So what you can see is it'll hopefully spit back some relevant documents. And then at the end, it'll do the AI generated response with information from our documents. So this is so cool. So let me just show you the AI generated response first, and we'll hop back up to the relevant document. So I was a little bit, a little cheeky. And what I did is I put in a document about myself inside of the book section, and you can see I have something. Oh, where did it go for you guys? Yeah, LangChain demo. And what you can see in here is, hey, if you want to learn more about LangChain, you can go over here to the official documentation. Or if you want more in-depth tutorials and insights on LangChain, check out my YouTube channel. And here's a link to it. Don't forget to like and subscribe, especially if you made it this far in this video. Don't forget to like and subscribe if you want to learn more about AI. But yeah, as you can see, it's generating an AI response that officially responds to our query in a conversational way. And you can see this is the exact document text that we were able to like manipulate and turn and use for our AI response. And if we actually look inside this text demo, you can see I put a bunch of information and we got back the part in our response for further explanation. Yeah. So in the way the chunking worked is we got this piece of text. And yeah, so I hope you guys think that is super cool for our one-off example. And what we're going to do next is I'm going to show you how you can have a full-on conversation with your RAG data. So let's go off and start working on example number 7. So welcome to example number 7 inside the RAG module. This is definitely the most complicated example in this section. However, it is the most useful one and probably the example you'll use the most often whenever you're actually building out a RAG solution inside of your applications for your users. Okay, so what we're going to do in this one is we're going to quickly speed through all the parts that are similar, and then we're going to focus on the parts of this code example that are different, that allow us to actually have a conversation with our RAG application so that we can, ask a question, follow up with it, get additional information from our vector store, and just keep going. So that's what we're striving to do here in this example. So let's go ahead and dive in. So in part 1, what we're doing is, per usual, we're just spinning up a vector store that points to all the books we've defined. What we're going to do is we're just going to use our usual retriever, which is just going to be a similarity one to get the top results. For this example, we're just going to use ChatGPT 4.0 as our LLM. Okay. So now let's dive into this part of the code that's all new. So the main thing that we're trying to do here, I think it's best if we actually start at the bottom to understand what's happening. So what we're trying to do is we are trying to set up this retrieval chain. All this is going to do is we want to be able to retrieve information from our vector store. We want to have awareness of all the conversations we've had up to this point. And based on the information from our vector store and our conversation, we want to generate a result. That is all we're trying to do. And that's what's happening under the hood. Okay, so how is this happening? Well, there's a few things that need to happen. Part 1 is we need to be able to grab information from our vector store. Well, how are we going to do that? Well, we're going to be using this library and function called create stuff documents chain. What does that mean? I know it's a weird term, but basically what it's doing under the hood is it makes a chain for us that will take in a list of documents and pass it to a model. So that's what it's doing under the hood. Okay, so we have documents and we need to feed those over to an LLM. That's exactly what this chain is going to do for us. So because we have OpenAI, and now you'll be like, okay, well, where do these documents, where does this conversation and documents come from? Well, let's keep working back up. So next is to create this document chain, we also need to provide some information about like what the heck's going on so that our LLM is aware of what it needs to do. Well, this is where we are going to make a prompt for us. We're just going to call this the QA prompt. So, question and answering prompt. And we're just going to say, hey, you're an assistant who does question answering. Use the following pieces of retrieved context to answer the question. If you don't know the answer, just say you don't know. Use 3 sentences maximum and keep the answer concise. So we're really just going to say, hey, here's the exact piece of information that you need to know from this RAG query. Okay, cool. So this prompt is then, we're going to use our prompt templates back from module number 2 to pass in basically just pass in our QA system prompt here to say, this is your system context. This is what you should be doing. And then we're going to pass in our chat history. Our chat history will happen later on. And that's as we chat with our LLM, we're just going to slowly build out a list of messages. And then finally, we're just going to continually add in the human inputs. Every time the human has a question, it's just going to get passed in as an input right here. Okay, cool. So now you understand how we have this question answering chain. So this is going to kind of set up the whole part where we're like responding to questions. Now we need to have what we're going to do and call the history aware retriever. So what is this? Well, the history aware retriever, this is where we're actually going to start passing in and working with our vector store. Retriever, remember, retriever is how we interface and pull information from our vector store. And we're also, you'll see here in just a second, but we're going to do something very similar to where we're going to have our AI, our LLM in this case, who's going to be doing the thinking and generating some responses. We're going to have a retriever, which is pulling down the information from our vector store. And then we're going to have a prompt, which just kind of sets the scene for what's going to happen next. So let's go part by part so this all makes sense. Okay, so for this history aware retriever, we'll go start with a prompt. So this prompt is saying like, hey, you're going to have some chat history and it's up to you to basically interpret what's being said and not answer the question, but just kind of provide context for what's going on. So this is all you're doing. It's up to you to reformulate the questions so that we can properly search for information inside of the vector store. So that's all we're doing. You're going to get a question, just rephrase it for the vector store so that we can retrieve the proper information. So I hope that makes sense. And then let's just go back and look at the other parts. The retriever we've already set up. We're just going to get the similarity score and we're just going to grab the top 3 results. And then when it comes to our LLM, we're just using ChatGPT 4.0. Okay, so now that we have all of these different things set up, we can actually go ahead, now that we have our full retrieval chain that has 2 parts, our history aware retriever, which is pulling information from the vector store, and we have our question answer chain, which is actually like taking in the user input and actually responding and generating answers to our users. Now that we have this entire retrieval chain set up, we're going to call it our RAG chain. What we can do is start having a conversation with our LLM and our vector store. So this is the exciting part. So I hope you guys like it. So what we're going to do is start asking, we're going to go ahead and run the program so you can see it in action, but I just want to show you at a quick level what's happening. First, we have a chat history, and that chat history was important because we were using it up here inside of our contextualized prompt just so we can have a historical reference to what's being said, okay? And we're also using it in our question A prompt. Okay, so we're constantly adding messages to this. So you can see here, whenever we invoke our RAG chain, we're passing in the user's query, and we're also passing in that chat history. Very similar to what we did when we were setting up our first conversations with our chat models in section 1. Second, what we're doing next is once we get the result, what we're going to do is just print it out for the user to see, and then we are going to append and update our chat history so that we have our initial query, and we get back the result from the AI, and we continually just add it and append it to our chat history so that it's aware, and we can have a full-on conversation. All right. Enough talking, let's go ahead and dive into the example so you can see that it's working. So what I'm gonna do is just go ahead and open up the terminal, clear everything out, and start our conversation. So this is in module 4, and this is example number 7. So what we can do is go ahead and run it, and then, it's gonna start our chat conversation for us. So we'll ask the same question we did last time. How can I learn more about LangChain? What this is going to do is go off and search through our vector store and actually spit out a response to us. So yeah, hey, to learn more, you're responding to us concisely like we asked, using the information from the vector store. It's basically consolidating it to 3 sentences maximum, answering the exact question. That's awesome. I also just finished Romeo and Juliet. How did she die? So this is kind of going out on a limb. Not sure if this one will work. I just want to show you guys that we can actually have a conversation with it. And we'll come back to my initial question in just a second. So that's awesome. I hope, fingers crossed, it'll come back and actually respond like, yeah, she kills herself with Romeo's dagger. So the cool part is we have specified, I just want to show you something. We specified do not. Basically, yeah, if you don't know the answer, just say you don't know. And what's cool about this is the fact that it's not making up information. It's pulling the information strictly from our RAG documents and going from there. So we can try and ask something else. So who is Brandon again? And this is where we're actually going to start using some more of the conversational awareness, because it's going to have to go, Brandon. Oh yeah, this is his YouTube channel. So we would expect it to refer up to 2 messages ago. Yeah, Brandon's the creator. You can find his videos here. So yeah, so it's kind of doing the full-on conversation part as well as the additional retrieval part where it's actually accessing our vector store. So I hope this makes sense to you guys. This is, like I said, by far one of the most complicated examples in this whole module and really this whole course. So if you have any questions, please head over to Skool. It's a free Skool community, and pop a question, take a screenshot and say, I'm stuck here, don't understand it, or I've been building this on my own and I keep getting stuck here. Please help. And myself or one of the other developers in the community will try and help you get you unstuck. But enough of this one. Let's go ahead and hop over to the last module we have, which is all about web scraping and actually using information we get from the web in our vector stores. So let's go ahead and dive over to example number 8 right now. Hey guys, so welcome to the final example in the RAG module. What we're going to be doing in this video is going over two methods for you to go off and scrape information from the web and add it to your vector store so that you can start asking questions and interacting with the data. And what we're going to do is I'm going to show you a basic example first so you can see it's working and show you some of the cons. And then we're going to go over to using a tool called Firecrawl, which is awesome. And I want to show you how it's going to perform a lot better and provide much more better results really. Okay, let's go ahead and dive in and go part by part. So the main thing that we're going to see for the beginning is same thing per usual. We're just going to set up our directories and set up our file paths. And this one, what we're going to do next is we need to start specifying a place where we want to start scraping the web. In this case, we're just going to go on apple.com. And what we're going to do is instead of using the text loader like we've been using for everything else, we're just going to use the web-based loader, which is going to go off and basically scrape a website for us. So it's, instead of looking through a book and loading it, it's going to just go over to a website and load the information. So that's what's happening under the hood. And then everything else is going to be identical. We're just going to split the text. Once we have split up the text into all the documents, we're going to start passing over basically those split up chunks plus our embeddings over to a vector store that you can see right here. So yeah, we're just going to create a new vector store from scratch, and that way we can start accessing it. Once we have set up our vector store, what we can do is start asking questions to it, and we're just going to use a similarity score. And this one, we're just going to grab the top 3 results. And we're not going to chat with this data at all. We're just, in this example, we're just going to get back results of like, oh yeah, these documents have the relevant information. Okay, so I'm going to run this one. We're going to look through the results together, and then we're going to hop over to Firecrawl after we kind of go over the pros and cons. So let's go ahead and clear this up, and then we're running we're in the RAG module. This is the 8th example, and this is the basic one. So what we're going to do, I'm going to zoom out so we can actually go through the results together. So it's going to spit out a ton of information. So this is just like the first one. So you can see that it's going like, okay, well, we got 5 chunks from the Apple website. Here's the first one where you can kind of see like, oh yeah, we're talking about the Apple iPhone 15 Pro. We're looking at, just some of the main key phrases, and we're adding all this information to our database. So that's just an example one. And then when it comes to actually asking questions to our vector store, we said what products are announced. It's just spitting back this information. So it's just like, it's saying Apple Intelligence, it's saying iPhone 15, iPad Pro. So it's really not like saying what's new, it's just kind of spitting out what's on the website. And yeah, it's just going to keep doing that and just return a bunch of information. Not super helpful. So, but it did work. We can actually interact, and it did a good job of web scraping. So plus on both of those. But the important part is I want to show you example number 2, which is using Firecrawl, just so you guys can see and compare and contrast the different results. Now, Firecrawl, it is a free tool that you can use. However, they do have they have some free usage for you. However, you do have a paid version. So let me just show you. Yeah, so they do have like a free plan and a hobby plan. But once you see how cool they are, like some of the results, I think you're like, dang, if you're doing a lot of web-based scraping, this is the tool for you. Makes your life super easy. Their key slogan is like, hey, we turn websites into LLM ready data. So like, here's a website that's gross. Oh, we'll actually pull like a markdown version of this data for you so that it's easy to use and interact with inside of your LLMs. So enough talking about it. Let's actually go ahead and use it. And the one thing I do want to point out is once you've signed up and made your free account, you will have to copy and paste this API key over to your environment variables folder that we have, or file that we've set up, and you'll just go ahead and paste it in there. So you'll just update the Firecrawl API, just put your key in your .env. You'll just put yours right here. Okay, cool. Enough of that. Let's go ahead and actually start running this so you can see how this Firecrawl example compares to the other one. And the only thing that I'm going to just say different, because some of this code is like, well, this is weird. What's happening? I will run through it real fast. Create your new persistent vector database for your vector store. We're going to call this one Firecrawl. And this time, because we can't just do web loader, which goes off and does everything for us, we actually have to be a little bit more specific using the Firecrawl loader tool. So this is a package that you can install. And if you actually go back to our pyproject.toml, you will see that we have, where is it down here? Yeah, you will see that we have a Firecrawl package. So this is how we're accessing this tool. But hey, we're going to use the Firecrawl loader. Here's our API key so you can validate that we are allowed to do this. Here's the website I want you to go scrape. And they have a few different modes. One's I think called crawl and one's called scrape. Crawl just goes through a whole website, and mode goes through like a single page. So I would definitely, I'd use scrape to start off with because you can easily blow all your tokens if you crawl. So once you have scraped that website, we're going to load all that information like we normally do. And what we're going to do in this one is we're actually going to chunk through that document that we have pulled out, and we're going to add a lot of metadata that you'll see later on. So it's actually pretty cool, the setup they have. And then what you're going to do next, split everything up into different chunks, pass over those chunks plus the embeddings over to a new vector store. And once we have that vector store set up, we can start asking and making queries to it. Okay, so enough of that. Let's go ahead and start, testing it out. So what we're going to do in this one, we're going to do Python and the RAG module. This is the 8th example, and this is Firecrawl. So we're going to go ahead and run it, and it'll take a few seconds to go off and scrape the website, beginning to crawl the website. And I might need to update my question just because WWDC 24 was a little bit ago, and I'm sure a lot has happened since. Okay, so the main thing is we grabbed 14 chunks of information compared to, whenever we were running the other example, we only grabbed, 3 or 5. So we're grabbing a lot more information because the Firecrawl does a much better job of actually, pulling out information. And it actually, I don't know how it worked under the hood, but they do a much better job of like getting around, like a lot of websites only load HTML. Whenever you try to use a tool like WebLoader, they only give you HTML. So you're missing out a lot of the JavaScript code that gets rendered. So that's how we're grabbing so much more information when it comes to Firecrawl. So under the hood, you can see now whenever we ask you, so you can see in a sample chunk that like, hey, we grabbed, well, for whatever reason, it chunked it too much. But you can see whenever we look at like relevant documents, we can start to see some of the updated questions that are related. Now, it didn't do a fantastic job, but let's update it to talk about Apple Intelligence. Yeah, whenever I wrote this first query, I made it for, basically I did it back in the day whenever WWDC 24 was about to happen. So now we're going to do a second question, and this time what it's going to do is provide information strictly about Apple Intelligence. So yeah, document 2, all about Apple Intelligence. So like I said, much cooler. You can actually see a lot more of like the links now if you want to go off and actually like interact and actually pull this information. And using a sales page isn't the best example. Using things like Reddit or places like that where you want to actually like pull actually a lot of content from like a lot of users' conversation, that's a great place to try out Firecrawl. So, but enough of that. I hope you guys enjoyed seeing how you can actually start pulling information from the web. You can go really deep into a rabbit hole when it comes to this, but just for now, when it comes to like scraping basics, this is plenty to get you guys started. But yeah, enough for module number 4, where we learned about RAG. And the next step, we're going to head over to start working with agents and tools. And this is going to blow your mind. So let's go ahead and head over to module number 5. Hey guys, so welcome to this 5th module in this LangChain masterclass. In this module, you're going to learn everything you need to know about using agents and tools. And before we dive into actually going through all the awesome code examples that I've set up for you guys, what we're going to do at a super high level is go through what the heck are agents, what are tools, how do they relate? And I will say, before I actually dove in to work with agents for the first time, I thought they were going to be this super magical thing that I would never understand. It was going to be super overwhelming, but it really wasn't. Once you, now that you've gotten this far inside the masterclass and you have a really good understanding of prompts and you have a good understanding of chat models and so forth, this isn't going to be too complex. So stick around. I think you guys are going to be like, oh, that's actually pretty easy to understand. So let's dive into it. What is an agent? Well, under the hood, an agent is nothing more than an LLM that has been provided a specific prompt to guide its behavior. So the best way I like to think of it is a state machine. And if you've never heard of state machine, it's basically just a machine that has certain states and it can perform different actions at each state. So let's just say it's at state 1. Well, at state 1, it can do something else. And once it's done with that, it goes to the next state. And basically, it will just perform a certain loop of tasks. And that's basically what a state machine is. In the same way, that's exactly how agents work. We're creating a prompt that defines certain states and behaviors for our agent to do. And what it's going to do is just flow through all of those different states, and at each state, perform a different action. So let's walk through it in this actual diagram, and we're going through it part by part. So the first thing that most prompts have inside of when they define our agents is they usually have an action state. And this action state says, well, this is where you can actually perform an action. So think of it, if we're creating a writer agent, well, the whole point of that agent is to write. So usually we'll say our end goal is to write a bullet list about what's going on in the news today. Well, this agent will know it needs to write a bullet list. So let's just say it starts off with our input and just talks about the recent Apple event, and it writes a bullet list. Well, then what it'll go is go to the next state where it can make observations about its actions. And from here, what it'll do is go, that was a little weird. You only produced 4 bullet points. Then we'll come back down to the thought. And when we are in the thought stage, this is usually where we'll plan out, plan is the key word here. We'll usually plan out what upcoming actions or behaviors we need to do next. So in this case, we'll go, oh, for whatever reason, we only had 4 bullet points. I need to rewrite my article or my bullet list and make sure I have 5 bullet points this time. So let's add 1 more. And then we'll just go back up. Action, we'll update our bullet list and have 1 more. So we'll hit a total of 5. Observation phase, yep, we have all 5 bullets. Things look good. And then now that we get back to our thought stage, we're going to say everything looks great. We look like we're done. And our thought phase will go, okay, cool. I no longer need to work as an agent. Here's my final answer. And that's a super simplified version, but really under the hood, that's exactly what's happening. An agent gets a specific prompt with an LLM that tells it how to behave. We pass in a goal and it'll just work towards that goal and just cycle through these stages. And there's a bunch of different types of agents, but this is the core loop that you'll hear about the most right here. Okay, now what the heck is a tool? Why do we care about it when it comes to agents? And when doing this course, at first I thought about breaking them up, but I didn't, just because they're pretty much useless without each other. And you'll understand why in just a second. So a tool is nothing more than usually some code and that provides our agents with additional functionality. So basically these tools provide our agents with superpowers is the best way I like to think about them. We give them upgrades is the best way I like to kind of think of it in my head. So a few common tools that you'll hear of are tools that will allow you to search the internet. So think Tavily, Serper, DuckDuckGo, there's a ton of these tools, and they allow our agent to interact with the outside world. Because if you remember, these LLMs, they have constraints. They're just, they have cutoff dates, and they basically, can only think thoughts and write text. And this is how we allow them to interact with the outside world. So that's what the search internet tool can do. From there, we could also set up our agents to actually execute code. So we can hook them up to an interpreter to like, oh, here's the Python code. Let's go over here. Oh yeah, you can actually now write and draw you can, run some code. You can generate some graphs with Plotly. Like you can do a lot of stuff when it comes to having your agents interact with code. The final one, you could also have tools that allow your agents to go interact with databases. So obviously so far we've kind of like hard coded and wired up in the past within our RAG section to work with a vector store, but you can actually set up tools to allow your agent to interact with a vector store, a SQL database. Like there's a ton that you can do. So it's just up to you to create those tools and then give those tools to your agents. And so just to give you an example, if we were trying to, find today's news, find today's like top 5 most talked about articles, and then plot them inside of a Python Plotly chart for like how correlated they were, something silly. But basically, we could do that with tools, because going through the same loop, we would understand first, I need to go off and find all the news articles and find the most talked about ones. Well, whenever I take that action, I'll search the internet, come back. I now have information about the outside world. Thought, okay, well, now that I have information about the outside world, I need to start mapping the information I found to some sort of chart where we can visualize how correlated everything is. Just, silly example. But now we come back to the action step and goes, okay, well, I now know the 5 most talked about articles. Now I can start actually generating code to make a visualization out of this information. So then I'll start executing code. Oh, nope, it didn't work. It didn't properly run. Go through it a few times. Okay, great. Now everything's working. Here's all the Python code so you can generate some graphics. So that's exactly how it works under the hood. And it's just going to keep going through this core loop. And we've now supercharged our agent with tools to go off and interact with the outside world and actually start taking some action. So that's enough of everything at a high level. What we're going to do in the rest of this example is I've provided about 5 to 6 different code examples that you'll see where we're actually like code everything up that we just talked about. So enough talking. Let's go ahead and dive into our first example so you can see all this in action. All right, guys, so welcome to the first example inside of the agent and tool module. Now, what we're going to do inside of this example is just walk through everything at a super high level because this is going to be the first time we're going to be introducing agents and tools inside of actual code. So we're going to go through it super slowly, and then after that we go through this example, we're going to later do a deep dive into agents so you can understand all the different ways we can use them, and then we're going to do a deeper dive into tools so you can learn how to use existing tools and learn how to create your own. So that's what we're about to do. Let's go ahead and dive into this part by part so you guys can master agents and tools. All right, so some of this is going to be super similar. To start off, we're going to be loading our environment variables because we need to use OpenAI. Now, the first thing that we're going to do in here is go off and create a tool. And for this one, we're just going to create a super simple tool that allows us to access the current date and time for our local computer. Because if you think about it, our LLMs, they were generated in the past, they have constraints and cutoff dates, and they actually have no way of knowing what time it is currently. So whenever we're actually using these LLMs in agent form, we can add a tool time so that our agents can access our current time. This is going to be super helpful as you go off to build larger and larger agents where they need to interact. So this is just a super basic one. So let's walk through what's happening. So the first thing is we're going to create just a regular function that all it does is it imports datetime, because datetime is just the standard library, and we're just going to grab the current time, and then we're going to return the current time in this format where it's hour, minute, minute. So that's all we're trying to do, and that's the whole purpose of this function. We'll dive later into why I had to set up our parameters like this for the function, but we'll come back to that later. All right, cool. Well, now once we have defined our specific function that we want to do, we have to wrap it inside of a tool. And later we'll get into actually like using existing tools, but for right now, this is just like how you can make your own simple tool with your own code. But basically all you do is you call the tool class, which comes from up here, LangChain core tools. That's how we can create a tool. And it's just up to you to give your tool a name, a descriptive name about like, what does this tool do? That way, whenever the agent's executing and it's like, oh, I need to solve a time problem. Oh, it makes sense for me to use the tool that talks about time. So that's why it's super important for us to give the name and description to be very representative of what's going to happen under the hood. From there, we pass in the function that we want the tool to perform whenever it gets called on. So in this case, whenever we say like, hey, give me the time under the hood, it's going to trigger this function, which is going to return our string representation of the current time. Okay, so that's how we make a tool. And that's how we add it to our tools list. And once we eventually have our tools list, we can actually pass this over to our agents. And you'll see that here in just a little bit. Okay, so now we've got tools out of the way at a super basic level. Now we're going to work on creating our agents. So if you look at this, you might be like, what the heck are we doing? What are we pulling? What is this word react? Well, react stands for reason in action. And all we're doing here is we are pulling out a prompt, because if you remember from earlier from prompt templates, all we're doing is pulling out a prompt template that tells our LLM how to act. So if you actually go and read what's going to happen at this prompt, you'll head over to a website like this. I'll actually copy the link for you guys so you can read it yourselves. But you can see kind of how we talked about earlier, an agent's nothing more than an LLM with a super specific prompt telling it how to behave. So this is exactly what's happening under the hood. This prompt template that we're going to create an agent around, it's just like, hey, answer the following the best you can. Here's the tools you have access to. And then that loop that we kind of talked about earlier, where you're taking action, you're making observations, planning out thoughts, and providing a final answer. This is exactly what this prompt template is telling it to do. So, hey, use the following format to basically perform actions. So, taking the input, think about it, take action. Here's the, like as we're working with tools, sometimes whenever we're taking an action, like get time, well, sometimes we might have to pass in parameters to our functions. So like, I want to get the time in Tokyo. I want to get the weather in San Francisco. So that's what actions like, use the tool, and then action input is like whatever parameters we want to pass over to it. So just hopefully that makes sense. Observation, hey, look at the results of the action. Thought, go off and here's what I need to do next. Basically plan. Yeah. So, and you can kind of see we're telling our LLM to repeat this over and over and over until we get a final answer. Okay, so that's what's happening under the hood, and we're actually able to, like, the part that's nice is it's kind of like GitHub where we're able to just pull down and reuse other people's code that's working. But in this case, we're just pulling down other people's prompts, which is pretty cool if you think about it. Okay, so now that we have our prompt, which is going to tell our LLM how to act, we need to keep chugging along, and we actually need to specify which LLM we want to create our agent around. And this time we're just going to use ChatGPT 4.0. That's the latest OpenAI model that's out at the time of this recording. And then from there, what we're going to do is go off and actually use the agent we've defined. We're going to pass in the prompt that we've defined, and we're also going to pass in all the tools we've set up to actually go off and create our agent. So if you look under the hood, what's actually happening in this create React agent, it's coming from the LangChain agents repo. So I'll just scroll up to the top so you guys can see it. But yeah, this is coming all from LangChain agents, and we're really just importing these two classes to create our agents and run them. But the main thing for our agents is we're sticking to that React part to where we are going to, reason about what we want to do, take action, and just continue that cycle over and over in order to actually achieve our goals. So this is kind of what it looks like under the hood if you want to actually dive in here and read more about what's going on. But really, we're just combining all the ingredients of everything that's needed to make an agent and just putting it into one class so that we can actually start passing information to it and running our agent. And that's exactly what we're going to do next. Once we have our agent, it's up to us to then pass in everything over to an agent executor. So an agent executor is just basically going to help manage the run of an agent as it goes off to solve problems. So if you come over here, you can see an agent executor. We're just going to say like, hey, this is allowing us to use tools. And if you actually dive into the code here too, you can see this is where we're going to be like actually performing the run and accessing the tools, putting information back and forth, and continuing to go from there. But really don't need to like dive into it. The main thing is just understand that like, yes, whenever I want to run my agent, I need to use an agent executor. Okay, cool. So once we have our agent executor set up, what we can do is once again, use our magical word when it comes to LangChain, and we need to invoke our agent executor to start actually spinning everything up. And what you'll notice is instead of just passing in a string, we're passing in a dictionary, and the keyword in our dictionary is input. This is the main thing that our agents expect to read is an input. So in our case, what time is it is the question that our agents are going to be answering. So enough of that. What we're going to do is let's go ahead and run it so you can see all of this happen in real time. So let's open up our terminal, and we're going to run Python. This is the 5th module because we're learning about agents and tools, and this is the first example. So let's go ahead and run it and see what happens. So what it's going to do as you go off and actually use agents, you'll see a lot of color-coded text usually coming out of the output as it's going through that reasoning, taking action, and making observations. So you'll usually see things like purple, green, and white. And this is anytime the agent's performing an action, you can see like, all right, what's the action I want to perform? So let me zoom in for you guys. So what's the action I want to perform? I want to get the time. So that's pretty cool that it was able to look through all the available tools that it had and pick the correct one. And then what it did next is it passed in an action input. And because we didn't specify any parameters for our tools, it just gave in none. But you'll notice sometimes when you're creating tools, and we'll dive into this here in a little bit, if you do not have any parameters for your functions, sometimes they'll mess up. So we just accept all parameters for arguments and keyword arguments, but we just don't do anything with them. So that's just a quick workaround. But what's cool is once we, perform the action, passing the action input, you can see here in blue, we get the local time back for when I'm recording right now. And then now that we have that answer from our tool, the agent goes, I now know the final answer. And once it knows it's the final answer, because if you actually come back over here, the thought is I now know the final answer. It then gives us back the final answer. So then that's super cool because you can see right here, it said the current time is 8:31 p.m. So that's the agent thinking. And then finally, under the hood, I've said that 100 times right now, but what's happening is it finally, now that it has the answer, it generates a object that it returns back to us. And you can see this object contains nothing more than the original input plus the output of the final answer from this agent. So that's what's happening. And what we're going to do next is, and I hope you guys, first off, I hope you think that is awesome because it's very cool that we can have agents reason and take action in the world. And, everything we're going to do from here, we're only going to add in more complexity and show off cooler features just so that you guys can master agents and tools. And just to dive in what we're going to do next, like I said, we have 2 different folders for you guys to go over all the different ways that we can use agents and tools. And the first one we're going to do is we're going to do a deeper dive into agents so that you can understand different ways that we can like configure these agents to work. And eventually we're going to hop over to showing you how to use more custom tools. So let's go ahead and head over to our first agent deep dive example and start looking at React Chat. Hey guys, so welcome to the second example in this agent and tools module. And in this example, we're going to go a little bit deeper into working with different types of agents and really expanding what they're capable of doing. So in this example, we're actually going to focus on swapping up the underlying prompts that we're using in the agent, sprinkle a few more tools, and then kind of add some chat capabilities to it so that our agents can now go off and do some internet searching for us and give us answers. So let's go ahead and dive into this example so you can understand what's going on. Okay, so to start, we're going to do the exact same thing we did last time, but we're going to add in some more tools. So this time we're going to do another get current time tool, exact same thing. And then next we're going to add in the search Wikipedia tool. And this is really just a function to go off and use the Wikipedia library. And what it's going to do is basically get a summary about whatever topic we're interested in. So we could ask questions about famous people, events, times, and Wikipedia is going to give us back a quick summary, 2 sentences of information it has on that topic. Okay, so now that we've defined those functions, we now need to package them into our tools list. And we need to format everything to be in the proper tool class. So that's where we're going to set up the name, a description so that our agent can go, oh yeah, that's the tool I want to use, and then the actual underlying functionality we want to trigger. Cool. So now that we have our tools defined for our agents, we can now move over to actually creating our agent. And what you'll notice in this example is we're using a different type of agent this time for our prompt, So last time we were just using the React agent, but this time we're using the structured chat agent. So what this prompt is focused on, it's actually having a chat. So if we head over to over here where we actually can see the underlying prompt template, it looks a lot different than the last one. So you can see like, hey, you're responding to a human with helpful information. You have access to the tools in our tools list. And I need you to basically create a JSON blob for these tools to go off and perform actions. That's enough of that. And then what's going to happen next is like, all right, cool. You're going to search for a question, go off and basically have thoughts about it, take action. So this is where we're going to use that JSON blob. And this is basically going to be like, information from the past that we've taken. Like, so whenever we get a response back, we're going to save everything as a JSON blob. And I'll keep it at that. But the main thing is it's going to allow us to have a conversation with our agents, and it's going to go off and, use tools to perform actions on our behalf. Okay, so that's what's happening under the hood. Now, what are we going to do next? Per usual, we're going to spin up a chat model. I'll actually go ahead and make sure we're using the right model. So we're going to use GPT 4.0. Make sure we're using the latest one. And then from there, what we're going to do is we're going to use this new, we haven't used it before, but it's called a conversation buffer memory. All it does is it allows us to store our chat history in memory. That's all that's happening. So in the past, we've done things such as, we'll literally just do like chat history and we'll save it to a list. Well, this is just a more, and we'll always add in our system messages and human messages. Well, this conversation buffer memory, it does a better job of doing it. So we're just going to use it for this one. It makes things simpler to set up for us. Okay, well, now that we have everything initialized, let's start combining things to go off and create our agents so that we can start running them. So per usual, we're going to create our agent and we're going to pass in the main ingredients, which are going to be our prompt, our tools that we defined in the specific LLM we want to use in the underlying agent. And then from there, what we can do is create our agent executor. And this is going to be, you can see we're adding in more tools to our agent executor. This time, these are the same as last time, our agents and tools, but now we're going to add in memory to our agent executor. And this is how we're going to keep track of our previous responses and messages with our agent, because we're going to be talking to this one. And what you can see from here is we're now going to, now that we have our agent executor spin up and it's ready to run, what we're going to do is go ahead and start our chat conversation with the user. So in our case, we can start chatting with our agent. So this is going to look exactly like our initial chat example we did, except now we've supercharged it with an agent that's not just talking to a vector store, it's going off and searching the internet for us to get responses. So this is super cool, and I hope you guys can see the value of it. So let's go ahead and hop down here and start running our agent. and actually seeing how it works. So I'm going to make this a lot bigger because you'll see how cool it is, because it's going to actually show us behind the scene what the agent is thinking. And before I trigger it, I do want to show you guys one thing. Let's go ahead and get the code ready. So agent deep dive, and this is example number 1. The thing that per usual, we're going to use the magic word when it comes to running LangChain tools. So the agent executor, and per usual, we do have to pass in the input. And you'll notice as you use these agents tools a lot more, everything's kind of structured as an input and an output. So that's how we can show the response from the AI. We're just going to say, yep, grab the output. And per usual, when the user submits a message, we're going to add a human message. And whenever the AI generates a message, we're going to add an AI message. Okay, let's go ahead and run it so you can see what's happening under the hood. So we're going to start off asking a question. We're just going to say, who is George Washington? And this will go off and use Wikipedia. So that's cool. It found the proper tool to use. And as you can see, it passed in the action input of like, well, who are we trying to query about? And it's so cool that the AI went from a question like who is George Washington to picking out the core topic of that question and then passed it as the action input. So it's amazing that this AI can figure out based on what parameters we need to pass in. Yeah, just grab the core part of it. So that's super cool. Now in the yellow, we're actually getting back a response from our tool. So our tool from Wikipedia says, you know, like, hey, here's everything you need to know about him, and so forth and so forth. And then once we have the final answer, it generates a response to us. So you can see the bot came back and said, yep, give us everything that Wikipedia said. So let's see, we can actually ask, because this is a conversation, we can add to our original question. So how old was he when he died? So because this is a conversation, we can actually refer to our previous messages. So in this case, it didn't even have to go off to Wikipedia this time, because it was like, oh wait, already know the information, so I can just use that to respond. And we can ask other things such as, who is Elon Musk and how old is he right now? So this question's a little bit more interesting because it's a two-part question. First, you have to go off and figure out who is the main person that we're talking about. So in this case, it's Elon Musk. For whatever reason, it's kind of struggling right now to find out who he is. But usually this is just a part of agents where it's just going to go in a loop until it finally gets an answer. For whatever reason, it couldn't figure out that one. So we'll just ask a different question, because I do want to show you guys the key underlying part. Who is Steve Jobs? And how old was he when he died? And the main reason I'm doing these two-part questions is because I want to show you guys how these agents can understand what we're trying to do. Yeah, and for some reason, I think Wikipedia is just crapping out on me. But the main thing to know is what would happen under the hood normally is these agents would go off and find the result for the first part, which is who is Steve Jobs. And once it knows the answer, it would then go off and actually find a, using the response, it would then trigger the next part and answer the question. So you can see like, yep, he's an American entrepreneur, obviously known for founding Apple, and he died at the age of 56. So that's very cool that I can do a two-part question. And you can even go deeper to where it triggers off a second Wikipedia call. But I'm not going to go into that for this example. So I hope you guys are like, wow, these agents are powerful. They can act on my behalf and go, find information, inform me, and I can just talk to them. So I hope you find that super cool. And what we're going to do next is dive into the next agent example that I've set up for you guys, where you can actually talk to a document store. So we're going to work on this one now. Hey guys, so welcome to the third example in this Agents and Tools module. In this example, we're going to be diving into how we can connect our agents up to a vector store so that they can kind of work together to answer questions about our data. So that's exactly what we're going to be setting up in this example. So let's go ahead and dive in. And what you'll notice is a lot of the information that I'm going to be showing in this module was built off of everything that we've kind of done in module 4 with RAG and all the previous modules before that. So a lot of this is going to look super familiar, so I'm not going to dive super deep into it. But to start off, we are going to be setting up all of our file path directories so we can point to our vector store. So this is the same vector store that we did earlier that read all those different books for us. So we're going to go off from there, set up our embedding so that we can actually, whenever we ask a question, we can embed it and compare it to all of our other documents to, grab the most similar answers. So we're going to then spin up our vector store with our vector database and the specific embedding function we want to use. And then we're going to use the exact same retriever that we used the entire time in the past. We're just going to use the similarity one this time, which is just going to grab the most similar results not worry about a threshold. In this case, we're going to grab the 3 top results. And if you remember, we used a 1,000 tokens per result, per document. So this is going to give us 3,000 tokens worth of information for our agents to use. All right, let's keep chugging along. From here, we're going to start working on creating our agents, or sorry, our LLMs. So in this case, we're just going to use ChatGPT 4.0. And then now we're going to be kind of combining 2 different examples. So in the past, we had an example where you could ask specific questions about the Docstore to the vector store that we've set up. But now we're going to be combining it with our agents. So this is the exact same demo we did before, where we kind of first set up like, just like contextualize what we're doing here in the first place. So like, hey, you are working with chat history to solve an answer. That's all you're doing. And the second part was the history aware retriever. So this is like, hey, go look at the previous questions that we've worked with. Plus you can look at you can use the retriever to go off and answer or grab information from our vector store. So this is definitely going to go a little in the weeds, but we already covered this in detail in our previous RAG example right here where we did RAG conversation. So you've already done this in the past. We're just now building on top of it. Okay, cool. Per usual, we're just going off and creating stuff from our document chains. This is how we can actually, if you go under the hood, this is how you can go about passing a list of documents over to a model so that they can be processed. Once we set up all that, we can set up our retrieval chain, which will basically be able to interact with our vector store. Okay, enough of talking about setting up our vector store. Now it's time for us to go off and set up our agent so we can have our agent communicate with our vector store on our behalf and perform actions and lookups information. So in this one, what we're going to do is we are going to use the same React agent that we did in the first time, which is just going to, think about stuff, take action, make observations, and just keep performing that in a loop. And per usual, when we're working with agents, we have to set up a tool. Well, this time we're going to set up a custom tool. And what's interesting is under the hood, this tool is going to do is it's actually going to invoke our RAG chain. So what's very cool is now anytime our agent has a problem or it needs to answer a question, what it's going to do is it's going to go, well, I don't know the answer to that question, but you know what? I bet this tool does, because it's useful for whenever you need to answer questions about the context of whatever the question is. So what's cool is all we're going to do here is we're going to invoke this RAG chain, and what we're going to do to it is we're going to pass in the input, so it's going to be the person's question, but we're also going to pass in the chat history so that we can have some contextual awareness of previous messages. So that's super cool. So now that we have made a new tool for our agent, we're going to go through the normal process of setting up and creating our agents so that we can actually start running them. So now that we have all of our agents set up with a proper tooling, we can now go into another while loop. And in this while loop, we're going to once again start chatting to our agent. So I'm going to come down here, we're going to clear things up, and now we're going to actually start running this example so you can see it in action. So we're going to do Python. This is the agents and tools module. We're working inside of the agent deep dive, and we're going to start using the React Docstore. So let's go ahead and run this one, and you can see, so we can start asking questions. And what's nice, already out the gate, we are, accessing the vector store. So because there was that one file I set up where I talked about LangChain, that's the first question I'm going to ask. So how can I learn more about LangChain? So what it's going to do is it's going to, well, this is a question I need to get an answer about. And then what it's going to do is actually trigger the AI to go off and get that information. And what's cool is like it responded with the exact part of like, yeah, this is, to learn more about LangChain, that what the document said was like, yeah, go watch Brandon's YouTube channel. Here's a link to the YouTube channel. So as you can see, that's pretty freaking cool. And then you can follow up because it is a conversation. So you can say, who is Brandon? And then it'll go off and actually, say, oh, he has a YouTube channel where he talks about AI. Does not mention the name Brandon. Oh, I guess I should have capitalized it. So yeah, that's how it works at a super high level when it comes to working with the Docstore. This example was a little weird, but I just wanted to show it to you guys just so you can understand like, oh yeah, you can really start connect these agents with basically different tools and use these agents in different ways. And I do want to show you guys real fast when it does come to the agent deep dive. I do want to show you whenever we set everything to verbose. Normally, yeah, so here in the agents and tools, I just want to show you guys when this is actually going off and grabbing the information. So we'll do this here, verbose, and I'm going to rerun this example just so you guys can see that it's actually grabbing from the Docstore, because I like to see the agent think. That's one of my favorite things. So whenever we run this again, we'll now do Python, fifth module, agent deep dive, example number 2. We're going to run it. I'm going to ask who is Brandon again. So, or how do I learn more about LangChain? How do I learn more about LangChain? And then now you can see it's actually, whenever it's running, you can see that it's saying like, okay, I need to answer a question about, I need to answer a question because I have no idea what is LangChain in the context of what I'm learning about. Okay, cool. Well, I'm going to call the answer question tool. The input I'm going to pass in is how do I learn more about LangChain? And then, so you can see, because we passed in an input, coming back down here to our code. Yeah, so here's our input. The query is now the same as this query. The chat history, this was our first question, so it's not updating it yet. And then the context, well, this is all the information that we get back from our vector store. So this is some information from our vector store. Some of it looks like it is, yeah, this is all documents from our vector store. And once it has those 3,000 tokens worth of information, it then converts that into a final answer that it then spits back to us that we can talk to here. So yeah, I hope you guys think that's super cool to see how the agent's thinking and operating, you know, whenever it's in verbose mode. But enough of doing the agent deep dive. What we're going to do from here is we're going to head over and start going deeper into different ways that you can create your tools so that you guys can master this and create your own tools and really supercharge your agents. So let's go ahead and head into that next. Hey guys, so welcome to the third example inside of the Agents and Tools module. And in this example, I'm going to show you guys the most basic way we can go about creating tools. And that's going to be using the tool constructor. And you've already done this a few times, but now we're just going to go into a deeper dive of understanding like, oh, that's actually what's going on. And here's how I can start making tools. So what I want to do is, to start off, I just want to show you the 3 functions that we're going to try and add to our tool set. So the first one is just going to be greet user. It's going to take in a name, and then it's just going to come back and say like, hello. We're going to do reverse string. All this is going to do is it's going to take in some text and reverse it and split it back. And then finally, we're going to set up a concatenate strings tool that just takes in 2 strings and concatenates them together and spits out a string. So, well, obviously, you know, that's just regular Python. Let's dive into the tool section where we're going to start using the tool constructor. So this is exactly what we've done so far whenever we've created tools in the past, where we've kind of set up a name, set up a description, and then define the specific function that we want to call. But the main thing I want to bring your focus to whenever we're using the tool constructor is this is a great way to go about creating simple tools, because all we're doing is just saying like, here's the name, here's the description, and then we're just passing in a function. We're not specifying anywhere the like, oh yeah, this takes in 2 parameters, one's a string, one's a number. Like, we're just relying 100% on the LLM underneath to understand what the tool needs and provide it to it. So, and most of the time that actually works really well. And that's whenever you just have a simple tool. This is the best way to go about it. It's super simple to do. And the part that I did want to show you guys as well is, if you're not using this complete basic way to create a tool, you can go off and use something called the structure tool. And the structure tool is great whenever you want to kind of set up more complex functions. So like this one takes in 2 parameters. So, you know, if you're doing anything that takes in more than 1 parameter, I would recommend going with a structured tool. And the part that makes this different is it takes in all the same information as before, except then now it takes in this schema. And this schema, we're just going to use pedantic, which is just a great way to like define basically like typed models. So we're just going to say like, hey, here are our arguments for concatenating string. I expect to have two properties, A and B, where A is the first string and B is the second string. So we're clearly defining, oh wow, whatever I pass in, I need to basically give 2 strings, and that's how it's going to work. So now that you've kind of seen how this works, I'm going to go ahead and actually trigger this to run, and so you can actually see all these tools working in action. And the only thing I do want to mention that we haven't shown so far is I am using a new prompt for this one. It's called the OpenAI Tools Agent. And what this one is doing is it's basically just focused more on using tools. So you can kind of see you're a helpful assistant. Here's your chat history. Here's your human inputs. So this one, all it does really is it's just, yeah, it works really well whenever you're trying to use tools. And so what we're going to do is go ahead and trigger this. And what we're expecting to see back is 3 different responses. One, we're going to tell the agent executor to greet Alice. So greet is going to hopefully trigger our first tool. And then eventually we're going to say reverse the string hello. And then we're going to say concatenate. And we're expecting our agent to go off and use the appropriate tools to make this happen. And we're going to log the entire process. Okay, so what we're going to do, come down here, clear things up, and we're going to run our example. So we're going to do Python, and this is the 5th module. This is a tool deep dive, and we're going to look at our first example together. So like I said, under the hood, this is going to go off and trigger each one of these. So let's look and see how it did. So for the first one, we said, hey, we're trying to greet Alice. So you can see that it said, I need to, invoke greeting user with the keyword Alicia or Alice, and what it's going to do is come back with an answer, because if you come back to our original function, all it was supposed to do is pass in hello and the person's name, and that's exactly what it did. So thumbs up for the first one. The next one is reversing the string, so you can see that, like, yep, we're invoking reverse string with hello. It did it, it performed the code, and now we print it back. And then finally, what we're going to do for the last one is concatenate strings. So you can see I need to invoke concatenate strings, and it did a really good job of creating a dictionary where it specified what is A and what is B. And this all comes back to the fact that we set up our structured tool and we passed in an argument schema. That was the magic that allowed this to happen. And now you can see that it did a great job of splitting it, concatenating it together. Okay, cool. So that was hopefully a quick deep dive into creating tools. And now we're going to go into the next module where we're going to start learning how you can use the tool decorator to kind of simplify some of this. So let's go ahead and start working on example number 2 in the tool deep dive right now. Hey guys, so welcome to the 3rd and final example in the tool deep dive. And in this example, you're going to learn how to create tools, but you're going to learn how to do it where you have the maximum control over how these tools behave. And what we're going to do in this module is we're going to set up 2 tools. The first one is going to be a simple search tool where we're going to go off and use Tavly to search the internet. And the next one is just going to be a multiply numbers tool, just a super basic one. So that's what we're going to be doing in this example. And I just want to walk you through the major parts together real fast, because some of this is pretty similar. So the first thing that we're going to be doing is setting up our pedantic models. And this is what we're going to be doing to define the specific inputs for both of our tools. So this is nothing new. You've seen this so far. All right, now let's actually dive into the part where we're going to create our tools and how we have maximum control over them. So the main way we're going to be creating our tools is by using the base tool class. Now let's hop over to the LangChain doc so you can kind of see it. So the main way it works is we're going to be using the subclass base tool to generate new tools. So we're going to inherit from base tools to create new classes that are tools, basically. So what you can see as LangChain says, like, hey, this is the way you can have maximum control over your tools, but it takes a little bit more work. And the part that's interesting is you can kind of see, like, we are basically using this example. I just want to walk you through the setup of it. But the part that's nice is you can actually set up your tools to have different functionality. So you can set up a tool to have a run. So you can see this is a private run method. And what you can see is we can actually say, hey, here's what you need to do. Here's your inputs. Don't worry about run manager. I've never really found it helpful. And then you can define the output. And what's super cool is you can actually, if you wanted to go even harder, you could actually define the output as a pedantic model. And if it fails during the run to generate the proper response, it'll redo it. So this is a really cool way if you plan on doing, spitting out some JSON, or you want to make sure that you print out an object that for sure has a person's contact info. So it for sure had to have the person's first name, last name, and email. You could set up a pedantic model as the output, and you can do that all here inside of your custom tools when you're inheriting from base tool. And then finally, you could set up things to run synchronously, or you can set them up to run asynchronously. We're just going to stick to synchronously for this example. Okay, so let's hop back over to our example. So the first thing that we're going to be doing is setting up a search tool, because we want our agent to go off and access the internet. Well, what we're going to do is we are going to do exactly kind of what we did in the tool constructor, where we have to give our tool a name, because we need to let our AI know, yep, this is the name of the tool, and here's when I would need to use it. Whenever I need to answer questions about current events. So, anything that's not inside of the AI's knowledge base. And then finally, what is the argument schema? Well, this is exactly what I want to be passed in, the simple search input, which just contains a query. Okay, now whenever this tool gets triggered and calls underlying run method, what's going to happen is we expect to get that query of a string of what we need to go search. Now here's where things get interesting. This is where we've kind of defined what this function should do. So in our case, we're going to use Tavily. And if you head over to their documents, this is how you can connect your LLMs to the web. And it just makes it super simple to go off and search the internet. And then I'm sure some of you guys are curious how much it costs. It's free every month for 1,000 calls, and then it goes up from there. But no, I've used them and I've really liked them so far. So definitely recommend checking them out. And to get started, it's super simple. You're going to basically just make sure you have access to this class. You're going to set up an account so you get an API key. And then once you have an API key, you can just start using their client and making requests. And that's exactly what we're doing in our code. We're importing that client that we would have installed. I've already added to the TOML file, so it's already going to work for you guys. Now we're going to, and then once you have your environment variables set up and grab it, you're just going to make sure you paste it in here. And once you've done that, you can now actually start using the client to make requests to the internet. So let's go ahead and we're going to run through the second tool real fast, and then we're going to run it so you can see that, like, wow, we are actually communicating with the internet, and it's super cool. All right, and the final one, this is just a super simple example. I just wanted to show you guys, like, yeah, you can create a tool to multiply numbers. This one's super simple. I just wanted to add it in here for you guys. But once you've created your two tools, what you need to do is you need to go off and basically in your tools list, we're going to create two new tools. So as you can see, each one of these is a class. So to create a new instance of the class, we're just going to come down here and just, create them down here. So once we have two instances of these classes, we're going to do the normal thing with our agents, set up the LLM we want to use, give it the prompt to guide its instructions, set up our tool calling agent. This one is a little bit different from what we've done in the past. In the past, we've been doing the React agent. So the tool calling agent, it just specializes in using tools. So that's what it's kind of doing. And then finally, what we're going to do is once we have our agent set up, we're going to use the agent executor to actually start handling our runs. All right, so let's go ahead and run our agent with these two different examples. The first example we're going to be using is search for Apple Intelligence. And I'm going to take off these quotes just so we have to make our AI learn a little bit more about Apple Intelligence. And then finally, we're just going to pass in a sentence, and we expect this sentence to get converted over to numbers that you can see, specifically floats, that we can then start to use to multiply. So that's what we expect to see happen whenever we run this. So let's go ahead and run it real fast. So this is in the agent module, and we are in the tools section, and this is the final one. So let's go ahead and run it so we can see the search results and look at just the math. So you can see out the gate, what it did is it said, all right, I need to do a simple search because that was the name of our tool. Let's come back up here, a simple search. And we just want to, what is the query of what we want to look up? Oh, we want to look up Apple Intelligence. So it pulled out the key topic. And then Tavily, our search tool, came back to us and said, well, here's your query. Here's what you want to look up. And then it gave us back the results. So it went off and searched the internet in a way to where we get quick titles, URLs. So if we wanted to, we can go off and actually explore some of these URLs and dive deeper. But you can see it came back to us with some more information about each of these things. And today is the middle of June, so you can see this is grabbing all recent information about what's happening with the new Apple Intelligence release. Okay, cool. And then once it gave us back the actual, like, this is the raw score, and actually you can see it here. Here's some of the relevant information. So it's just putting it in a nice format for us. That's what's happening with the tool. And once it has that information, it's just going to spit out the final response for us. So you can kind of see it all right here. This is the final response and the output right here. It's just going to look exactly, this is basically the output. If you printed it out, that's what you would see that you were to pass it out to your user. Okay, and enough of that. The tool went super simple. The reason why I kind of like this example is because usually tools struggle with, like, if you were just to run this as a regular tool decorator, for whatever reason, it kind of struggles to recognize, like, oh yeah, that's a float. So I just thought this was a cool example of, like, oh yeah, we have to convert a string to a numerical representation. So yeah, and we get back the correct answer, and it's a float, which is what we want. Okay, all right, so that's it for the tool example, and this is actually it for the entire agent and tool deep dive. just to like plant some seeds in y'all's brains of like what else is possible. CrewAI is by far one of my favorite products out there when it comes to working with agents, because they make it super cool for us to actually set up agents to work with other agents. So right now we have one agent, performing a task. But what happens if you had like a writer agent collaborating with a researcher agent who each specialize, like if the researcher agent specialized in exploring the web and the writer specialized in writing articles that had a good rhythm, used proper like languaging to write interesting articles. Well, these guys could work together to generate an awesome report. So that's just scratching the surface of what CrewAI can do. But I just wanted to like plant some seeds for like what's next after you guys learn like how to make an individual agent. Well, multi-agent tools are the next, and I definitely recommend CrewAI. And I have a ton of videos on CrewAI inside of my YouTube channel, so I definitely recommend checking that out next. But yeah, that's it for the 5th module, so let's go ahead and wrap things up. Hey guys, so I hope you guys have enjoyed this LangChain masterclass. We covered a ton of information in all 5 of the different modules. Hopefully you guys are now pros when it comes to working with chat models, prompt templates, chains, RAG, and your agents and tools. And just as a recap, all the source code in this video is completely for free. There's a link down in the description below. While you're down there, it would mean a lot to me if y'all could hit that like and subscribe, especially if you made it this far in this video. Also, there's that free Skool community where you can meet like-minded AI developers, and we have those weekly free coaching calls, so you'll definitely want to take advantage of that. And then outside of that, I have a ton of other AI-related content on my YouTube channel, everything from Fullstack AI tutorials all the way to like CrewAI deep dives, so you're definitely going to want to check out one of those after this video. But enough of that. I hope you guys have a great day, and I can't wait to see y'all around in the next one. See ya.